The prophecy in Fontaine? Oh no.
Alright.
Now,
Hello, hello, hello. Countsake here, back with another Genshin Science live stream. I think that's enough playing around now. I'll probably go ahead and start things off. So, if you haven't seen the last live stream, I ended off very confused. Yeah, it was just a time where I was just like, what the heck is happening? So, yeah. Hello, Rad. So, nice to see you all in chat. Nice to see you, Nebis. It's nice to see you all. So yeah, last time I ended off very confused. Okay. Last time I ended off very confused, and that was a lot shorter than I thought it was gonna be. Okay. Never mind. Sorry, Marissa. Maybe you're more of land running than water sprinting. Okay. And I'll also just bring out the crew here. Flat Teyvat crew. So, in the last time, let me just do a quick recap. Very, very quick. Nothing too much. Basically, I considered where is it? There it is. Okay, there's some... You can probably barely see it on stream, and I apologize. But there's like this really tiny thing over here, and I basically tried to measure its height, in a sense, to essentially gauge how, according to some, like... Okay. Dear gosh, I need to think about how to properly explain this. Okay. So you have a radius of, we have, the claim is that the Teyvat of radius is 1,778 kilometers. And well, I tested that by seeing how far away from an object with a specific height, how far away from it do you need to be so that it's no longer visible because of the curvature. And it turns out that this thing over here that I'm looking at is what I was looking at all the way in Musk Reef. I proved that in the last stream, so I literally took the Wave Rider and drove it all the way back here. So if you want to be able to, if you want to see that for yourself, prove that it's actually the same thing, you can watch last stream. All right. Oh, hello. I just love Latina Sonic. I understand nothing. It's okay, it's okay. Do you need me to... If you want, you can ask questions. I'll be more than happy to explain a bit better, because I can understand that what I do is probably rather technical. It's okay. Whatever. You can imagine that on a circle that... You can't, like, for example, if you look at one side of a sphere or a ball, you can't see the other side. Like, if you put a sticker on one side of the ball and then turn it around, you won't be able to see that sticker anymore. But, of course, there's probably a point where if you rotate the ball towards yourself, you will be able to see that sticker. Another way to think, and then, well, imagine instead of it being flat on the surface of the ball, you can have it be sticking out of the ball. So, like, there's... Yeah. I don't know how to describe that, but I guess if you stacked, like, a million, or not really a million, like 100 stickers on top of each other, it would technically be like a building. And yeah, there would be a point where you might not be able to see... Where you'll be able to see it, and where you might not be able to see it. The point is, when you have curvature, the height... or the objects will disappear over the horizon. That's basically it. It looks like objects would sink below the horizon. That's all it is. Nah, I'm good. I wouldn't probably understand. It's okay. It's alright. Don't feel too bad. Some of this stuff can be a little complicated. Alright. in this video, or not video, this live stream, in this live stream, I will be testing out a different method, because last stream I was not conclusive about whether or not Teyvat is curved or if Teyvat is flat. Or at least I don't have any conclusive evidence to say either one. Personally, I think it should be flat because that makes the most sense from a game dev perspective. Like, really. And, I mean, kind of just look at it. It's flat. It has to be flat. And some people have literally, you know, there are some people who know how to go out of bounds and whatnot. They literally go to the edge and, yeah, it looks pretty flat. So Teyvat should be flat. That's the gist. But, funnily enough, from my last stream, I could not say that Teyvat was flat with 100% certainty based on what the evidence I collected alone. And that's what's very confusing to me. And so, how exactly am I going to test it now? Well, funnily enough, the paper that made the claim of, you know, the 1,778 kilometer radius for Teyvat, they actually proposed a specific height method. Let me see if I can find Celestia. Whoops. Okay, so the person who proposed the 1,778 kilometer radius for Teyvat... where's Celestia? So game devs are a flat earther. I mean, it doesn't mean that they're a flat earther, it's just that it's a lot easier to make a flat world in a game. I mean, I guess if you want to think of it like that, you can. Flat Teyvaters. Yes, exactly, Phantom. Flat Teyvaters. So I am a part of the Flat Teyvat group, because there is no reason for the game devs to really make a curved surface for their planet, and much less accurate to 1,778 kilometers for a radius of curvature. Where is Celestia? Oh. Wow.
Say cheese.
Wow. That was a lot closer than I thought it was. You know, maybe I'll back up a little bit because, that's a little too close. Is it still also just nearby? I don't know if I can see it from here. It's still too close. Okay, I'll go here to Petrichor. Where is it? It should be somewhere. Somewhere, okay. Where is it? There it is. Okay, there it is. It's kind of blending in with that cloud there. So, what the person did to... Well, they had to determine the height of Celestia off the ground. And the way they did this was essentially by using angles. Or, yeah, they used a bit of trigonometry. I'll just replace Farina here, so I'll just bring out Yellen.
Who's our target this time?
So what they did is essentially they would reset the player's, like use the middle mouse button to reset the player's angle, and then they had like something slowly, or they just slowly tilted their camera upward until they were like looking at Celestia. Now, I personally don't think that method was very accurate because, for one, I don't believe that when you reset aim, I don't believe you're at an angle of 0 degrees, which is what they assumed. And The other thing is that, yeah, they also mentioned this, that they don't know if, like, the change of angle is constant per inch of mouse moved. So, yeah. But instead, what I decided to do is to come up with something, a more similar idea, but this time using pixel measurements. And luckily for us, we do have a horizon, so we can have a reference for a 0 angle. And then I can just look up at an object, or whatever object, it doesn't have to be Celestia. I can just look up, and I'll be able to figure out the height of the object if I know the distance between myself and the object. I can figure out its height. Yeah, and this is all possible. And well, to get a basic understanding of how this is possible, it's time to bring up some math. So we always need some background before we do any sort of studying, or before we do any sort of experimentation. It's always good to get some background in things. So, give me a moment. I'll just be opening up Paint Tool Size soon. Phantom is asking, what height did they end up with? Okay, I need to check that, so give me a moment. I'll open up the research paper. I know they had they literally even had, the person literally created a document for this. It was a meme. It was, the thing was a joke. It's for fun and giggles, so yeah. They literally went so hard on this joke. I respect it. I respect the joke. So, okay, I'll open up the document that they actually posted. Give me a second. I'll switch to the desktop. Here they are. Here it is. Okay. Radius of Teyvat. And we just need to wait for this to compile. Okay. PDF in separate tab. And, okay. Here. Yeah, this is the actual paper. And, okay, finding the altitude of Celestia. They essentially, where is it? We find out that, oh, okay, no, where is it? Dear gosh. Altitude of 1074.724 meters. I don't know how accurate this was, and keep in mind that I don't know if that this paper was published a while ago. This paper was released a while ago. Where's the bibliography? Okay, there. So this was back in 2022 or 2022. So like yeah, Celestia, I'm pretty sure back at that time Celestia had a different position than what it is now. So that is something to keep in mind. And I don't really know how accurate this height is. So 1574.724 meters. Alright. Now I'll go back to Paint Tool Sci, so that way I can actually explain the actual math behind this. So this is basically just trigonometry. So let's start off with what we're all familiar with, a right triangle. So we have a right triangle like this. And then, of course, we'll have some length. We'll call this, or actually, we don't really need to know the hypotenuse. We'll just do it like this. We have some distance. Trigonometry, my weakness. It's okay. It's not going to be too anything complicated. So we'll have some distance like this. And then we'll have some vertical distance or vertical height like this. Why not? I'll also label the hypotenuse. So we'll do it like this, if I can draw this correctly. And I'll label this to be L. Or no, not. I'll label it to be R. And we'll assume that the angle here is theta. Alright, so the one thing to remember from trigonometry is probably this. SOHCAHTOA is SOHCAHTOA. So the S, it basically stands for the sine function, so sine. This one will be cosine, and this one is the tangent function. Then the O stands for the opposite. Dear gosh, my handwriting. The opposite side relative to the angle. The A is the adjacent. And H is the hypotenuse. Alright, so opposite, adjacent, and hypotenuse. So we always know that the hypotenuse is the longest. So by default, that means that it is going to be this one. It can't, so we already know that this top one is H. I'll just leave a little note here. Now, depending on where on your angle, the opposite and adjacent, stuff changes. So I can also label this upper side as alpha. So, relative to theta, we'll start with theta here. Which side is going to be the opposite? Well, you take a look at where the angle is situated. And, well, just you go in the opposite direction. It's kind of just how it is. So it can't be this one because it's not opposite to it. Why is it? Because it's literally right next to it. Or if you another way you can think about it, the adjacent always has to be connecting with. Yeah. Okay. Enraged Coffee says, Teyvat is set in a snow globe world, so it is flat. Yes, I very much am pretty sure that is the case. I'm pretty sure that is the case, but for some odd reason, I could not prove that the Teyvat was flat last time. For whatever reason, I couldn't prove Teyvat was flat. I tried doing some math, or you know what? I'll open up the physics or the math paper. I'll open up the doc. What derivations I was doing last time. That's what I'll do. Where is it? Radius of Teyvat check. Call it math. Okay, so just as in response to the Latina guy. Oh, okay. I'm learning more here than in school. Okay, so yeah, basically this is a bunch of the math I was doing last time. So anyway, the adjacent is the easiest to spot because it's always next to the angle. It is always it's always next to the angle. However, you have to be careful here. We already know that this is the hypotenuse, but it is also touching the angle theta. So, but remember, we already assigned this one as the hypotenuse, so you cannot assign this the adjacent. The adjacent has to be next to the angle, so it will be this one. And therefore, that means that the opposite side is here. Alright. Could be flat in the lore, but maybe not in the game itself, though. I'm pretty sure Teyvat could... I don't know. I can see Teyvat having a radius. It's just that the radius would have to be extremely large. But as far as I know, I don't know. Okay, though maybe if we know the size of Teyvat, we could know how tall the globe around it is, limiting Celestia's height. You could. I mean, you could. I mean, the paper I'm referencing that calculated the radius to be 1,778 kilometers actually did already calculate a height for Celestia, but I question its accuracy personally. I've mentioned why in one of my videos, but yeah. Anyway, enough about that. Let me actually continue with this. So we have the adjacent and the opposite. So how do you now actually set up this sine theta? So yeah. So now we have to figure out our trigonometry functions. So we have sine theta, cosine theta, and tangent theta. So let's also interpret these little things here. So when we say so, what we're saying is that sine of some sort of angle is equal to the opposite divided by the hypotenuse. We also say that cosine for whatever angle it is going to be the adjacent divided by the hypotenuse. And lastly, tangent is going to be the, what is it, TOA, opposite divided by the adjacent. Oh, whoops, that's not how you spell adjacent. Dear gosh, I know how to spell. All right. Just know because restricted to a small part of it. Yeah, that's kind of how it is. I mean, even with the actual Earth, we are so tiny in comparison to the actual size of Earth that we can barely see the curvature. It's possible to see it. It's just that it takes a lot of it's a little bit difficult to see it with your own bare eyes, especially when you're close to sea level. Anyway, so yeah, these are how you calculate sine theta, cosine theta, and tangent theta. The opposite. So let's start with, again, since we're considering the angle theta, let's start with sine. So the opposite is this. Okay. Let me also label this. I'll call this ry, and I'll call this rx. The opposite side is ry, so therefore we'll have opposite ry divided by the hypotenuse, which is just r. So there you go, sine theta. Next for cosine, we have the adjacent, which is rx, and then you divide by r, because that's the hypotenuse. Not too bad, see? And now again, for the last one, we have opposite ry and the adjacent rx. So opposite ry divided by rx. There we go. Now we have equations for the different trig functions. And in fact, if you want, you could even, you can solve for, if for example, if you know the angle and you know the hypotenuse, you can solve for this. Or if you know this one, you could also solve for this. You could just use algebra to solve for what you need to know. And in fact, you can even solve for the angle here if you need to, using the inverse trigonometric functions, which can be seen as inverse sine. I personally hate this notation, so I like to use arc sine or arc cosine or arc tangent. Yeah, those are the ones that I like to see. Now, what about this angle alpha here? We got to be a little bit more careful here, because what if we wanted to figure out the relationships sine of alpha, cosine alpha, and tangent alpha? we have to be careful here now because we now have different arrangements for the opposite, adjacent, and hypotenuse. Well, actually not all three of them, because we already know which one is the hypotenuse. It is always the longest of the three. And, well, in this case, it's just going to be R. But what about the adjacent side? Well, the adjacent side has to be touching this one, and it cannot be the hypotenuse, so it has to be this side. The side that's touching the angle theta, or not theta, alpha, is this one, or this one. But this is the hypotenuse, so we can't use it. So this side is the adjacent. And that only leaves this one to be the opposite. Excuse me. And you can see here. So now we can do the same thing. So the opposite is going to be Rx this time. Rx, and you can divide by R because that's a hypotenuse. You do the same thing. The adjacent, that's going to be Ry divided by R. And lastly, tangent, the opposite is Rx divided by Ry. And there you go. So it's always, whenever you're doing trigonometric functions, particularly with sine, cosine, and tangent, all you gotta do is to keep in mind the hypotenuse, the opposite, and the adjacent, and then you're able to pretty much get the equations you need. And this is all the background we really need. So, in our case, in Genshin, what we have is that we have the player, so we'll assume that this is like the traveler or something. Let me draw out the traveler. He's like all the way over here. He's got his dual blotte. Never mind. Okay, so yeah, traveler here, and he has his ponytail, something like that. I don't remember his hair off the top of my head, so I apologize. So there's a traveler. And we can imagine that there's some object with some height. We'll call it some height, and it will be like this. Some height. Let me try to draw this. Sorry, let me focus and try to draw this. So we have some object that's like this. And this is the ground where the traveler is standing. Or I don't know, it could always be some rough terrain, but it doesn't matter. Point is, relative to the traveler, we have this. And it has, and let's assume that it has a height. Come on. There we go. It has a height of, come on, h. We can also say that, okay, this is a little awkward, but let's assume that, okay, let's also assume that the traveler is just like level here because with the ground or something, I don't know. The point is, whatever, we'll assume that we'll just take it from the feet and just do it like this. And this will have some sort of angle theta. And then lastly, we know we have the distance between the object and the player. Well, we can now, and I'll just call that distance, what will it call? I'll just call it D, a distance D. If we can figure out, if we know if we know the distance and the angle, then we should be able to determine the what's it called? We'll be able to determine the height. And now let's go back to our trigonometric functions. Which trigonometric function would be particularly useful here? So, let me just put this down here. That way you can all see here. So, in this case, we have, this is a hypotenuse, but we don't really need to know what the hypotenuse is. In fact, we can just completely ignore the hypotenuse. So, we only have an opposite and an adjacent. And well, out of the three that we have here, the one that doesn't have the hypotenuse and actually has the opposite and the adjacent is the tangent function. So therefore, we can use that to the tangent function to determine the height. So tangent theta is opposite, so that's the height, and the adjacent is the distance. And just multiply both sides by d, and you get that the height is equal to the distance multiplied by the tangent of the angle. There we go. That is all the background that is needed to really calculate the height. But hold on. I'm missing something here. How do we exactly determine the angle? Because now we're dealing with something about a bit more complicated. We have to now figure out the height. Or how do we or sorry. Let me, I'm stupid. Okay, what I meant to say is that I'm saying that we're assuming that we know the angle theta, but how do we get the angle theta? Do you I mean, I know how to do it. I'm just trying to see if do you guys actually would you guys be able to figure out how you would be able to do this? Okay, I'll just go back to Genshin for a bit. And yeah, okay. I just love Latina Sonic. It says they have no idea. Alright. You know what? Okay, I'll just say. Basically, I already gave a little bit of a hint of this earlier. But something we can do is that we can make use of let's see if I can, you know what, I'm gonna bring back Farina. No, I can't. I need Moose on the team because he's the OG the sky is fake guy. Come, you can't tell me he wouldn't be in on the conspiracy. I'm really sad I missed that event, though. I was playing at the time, I just didn't do the event. I'm really sad I missed that. I'm really sad I missed the reconciled event, stars event. So, okay, the way we actually measure the angle is, well, for one, I'm purposely positioning Yellen into the water like this, so that way her eye level is approximately, her height is approximately level since, you know, her eye level is...
All right,
Yellen.
maybe I'll take one more day off and knock out the rest of the work once I'm feeling up to it.
Man, I haven't done any type of algebra since 8th grade. My high school experience was, it's alright, Nebis. It's, yeah, it's just what it is what it is. It's, I mean, I try to actually explain it a bit. Hopefully you were able to understand the whole trigonometry stuff that I presented earlier. Enrage Coffee says he really wants his gnosis one way or another. Yeah, okay, so,
I got a new letter from an informant.
Yellen, shush. Okay, so, we basically, we use the crosshair here, and then we could angle it slightly upwards, and then we can measure the distance from the horizon to this point in pixels. And then from there, if we can use that to actually measure angles by using the horizon. Now, I'm using the horizon as the reference because that is where the angle 0 is. Theta, or the angle 0, will have to be with the horizon. Or approximately so, because it's just so... the horizon is so big in comparison that you might as well just consider it an angle 0. And after all, yeah, you can see. It's approximately 0. Yep, more or less. It's a little awkward because it's like you're kind of above it. There we go. Yeah. Now, I did some work off stream, and I actually did a bit of measuring because I wanted to see something. So I'm gonna open up a spreadsheet that I created. Let me just find it. Where is it? Where did it go? Is it here? Okay. Here it is. I essentially created a sort of little... I essentially did a bunch of stuff involving experimentation. Just like this. And... okay, actually I should probably go into Genshin first. Hold on. What I'm going to do is I'm gonna go into my teapot. I said I'm gonna go into my teapot. First try, easy. Definitely no problems there. And show you a little, what's it called? A setup I made for this. Alright, so here we are, and let's go all the way over here. You can use your map, it's faster. Oh yeah, I always forget, I always forget that. You can open up the teapot and you can open the teapot in the... I always forget that you can do this. And then just teleport. I always forget about it. But the point is, I set up this little thing over here, and you can see we got some platforms.
Quit following me.
And to do this, I'm just gonna take a really quick screenshot here. Gonna take a screenshot, and I'll put this into Paint.si here. And, well, yeah. And then I'll go over here. Or, actually, yeah, I'll just go into Paint.si first, but yeah, I'll just go. Wait a minute. I'll do this. Okay. Paint.si. That I can actually explain stuff. Alright, there we go. So we have a little side view of this thing. Doesn't this look a little familiar here? So, let me lower the opacity so that way you can actually kind of see. We have some sort of distance here. We have some sort of distance. We'll call that D. And then we have a little bit of some sort of height. A height H. And yeah. Now, there's one thing I don't actually explain. So you can actually see here that we have a right triangle. But there's something we need to keep in mind. When the player is standing on the wood here, when the player is actually standing on this wood, like with Yellen here, her eye level is not, or whatever, her crosshair here is not, when it's at 0 degrees, it's not gonna be in level with this one, this bottom part here. And to take into account that extra height, I have this little platform right in front, this one. This platform here is the minimum height, or actually to have as angle 0. So if we aim like this, you can see here, I will be able to actually shoot above it. But if I was to raise that just a little bit higher, it would actually completely stop all of Yellen's charge shots. If she's aiming horizontally, that is. So this little platform right here is the reference for our 0 degrees. And yeah, as you can pretty much see, if we can actually just aim just above it. So that's our 0 degree reference. And then what I can do is I can raise my cursor up, try to align it with this platform up here, and then I can measure a height in pixels relative from this top platform to this one. And from there, I can now correspond that pixel height into an angle using trigonometry. But of course, I also need to know some other things. For one, I need to know the distance between that point and this point. This point. There it is.
Take it easy.
Luckily for me, I bothered to also measure that myself. I have done a bit of measuring and stuff, so there's quite, yeah. I've done a lot of work. So, let me see if, did I put it here? Okay. Did I... Dear gosh. Oh, okay, I have a little drawing. Okay, I'll show it to you on Paint-Tool-Sai. Let me also just do this. So, in Paint-Tool-Sai, here we are. This is pretty much a replica of our little setup here. I'll just bring... Yeah, I'll bring this thing over. So I'll copy that and I'll paste it here. Hopefully you can see it, see the semblance. Whoops, it's a little faint. Let me raise that opacity just up a little bit. You can kind of see it. It kind of looks like it. Whatever, it's supposed to be a side view and it's just a drawing. So the point is, we have some initial height off the ground, and then we also have this YP, or call it Y player or Y platform. This is for our height for 0 degrees. And lastly, we have some height above the platform. And then what you can see here is that you can actually create a little... What is happening? Okay, you can just make a little triangle right here. A right triangle right there. And then you have this side is delta x and this side is delta y. And then you have a tiny little angle like this. And yeah, from there we can now associate the stuff. And well, yeah. So I already measured this stuff. I measured the width of one single platform because there are actually multiple of these platforms stacked together. I put 4 of them, I think. So, yeah, 4 of them. So delta x is fixed at 18.524 meters, and then this x, and then we have yp. Yp depends on the player model. In this case, I'm using Yellen, so it will actually have a height of 1.4 meters. And lastly, this Y0. If I go into the game, I can... Oh wait, hold on. So I'm actually I just realized there's a chat, but it didn't appear in my thing. Okay. I just love Latina. Sonic says, I may not have a brain, gentlemen, but I have a theory. Notice that the tides never change in Genshin, so that means that the moon is really fake and Teyvat is flat. Yeah, sure, it could be. It could be. Anyway, yeah. Anyway, enough. Let me continue. What was I doing? Right, the height, the initial height off the ground. If you actually go into the editor, what you can notice is that you actually have a platform height here. So you can see that you have a platform height listed here. Now you might notice this is 1.1 over in this side and it says 1 over here. I'm guessing that's because the ground is not perfectly flat, so it actually does have a little bit of a height difference between the two. Or like maybe it's like slightly angled and then it just so happens that there's a 0.1 difference in height between the two. As far as I can tell, these heights do pretty much exactly correspond to meters. So this is 1 meter off the ground. And since this is the closest one to these platforms over here, we can basically say that y naught is 1 meter. 1 meter relative to these tip points. And yeah. And this one will be 2.4 because we have 1 meter plus 1.4. Yeah, there we go. And that's it. And then from there, we actually already know the heights. So we have a height of 8.3, but we have to subtract that by 1 and 1.4, which is 2. Yeah, we have to subtract the height 8.3 by 2.4, and that will give us your delta y. And we already know our delta x. We calculated. It's going to be fixed in this little experiment. Well, I've already done the experiment, so it's not really... Yeah, so... Yeah, you do like... we already have our delta x, we have our delta y for whatever platform you're going to consider. And then, all we have, and then from there, what you'll have is the angle. So, you know what? I'll go ahead and calculate it. I'll just go ahead and calculate with you guys. So... we know our distance. Whoops, let me make sure to go to Paint Tool Sci actually. We know our distance. Our distance is going to be equal to, what was it? 18.5, okay. 18.524 meters. Then our height, we'll consider that to be 8.3. 8.3 meters. Or, wait, hold on. We have the actual height of the platform, which is 8.3. So I actually need to do this. Delta y. So delta y is 8.3 meters. But you have to subtract by yp, which is 1.4 because we're using Yellen. And you have to subtract that by the height off the ground, which is 1. So yeah, then from there you have delta y is equal to, let me get out my calculator, because we need to actually do that. 8.3 minus 1.4 minus 1. And that will be equal to 5.9, or 5.9 meters. And then, again, yeah, all we need to do now is simply use the tangent function. So, tangent. The tangent function of theta, or tangent of theta, is equal to, well, that's going to be equal to delta y because that's the opposite, and the adjacent is delta x. And then from there, we can make use of the inverse or arctangent function to solve for theta. So theta is equal to arctangent of delta y of delta y divided by delta x. So if I plug in the numbers, if I plug in these values of delta y here and this delta x into there, we'll get an angle. So, inverse tangent or arctangent of 5.9 divided by 18.524. And that gives us an angle of about 17 degrees. So let's see, 17.667 degrees. And that is the angle of that little platform here. And that should be the angle that we make when, hold on. Oh, that should be the angle that we make when Yellen is all the way at the back here and looks up to this first diagram. So that is, this angle here is 17.6 degrees, more or less. Now, if I was to, now the next thing I could do is to actually take a bit of a screenshot. Or, yeah, what I can do is to take a screenshot. So, I'll do just that. Take a screenshot. And from there, I can open up a video editor. So give me a second here. I need to open up Photopea. All right, Photopea. Bring it up, Photopea. And I just need to find my screenshots folder. So in my screenshots, I can bring over this screenshot here, just like that. And now what I do is I'm just going to draw a line, have a fill, and the width will be 0. And we measure the pixel difference in the height like this. So we can see here, I'm drawing like this rectangle, this line that, and I'm gonna have it be just above the platform, like this. Or maybe I'll put it up by 1 pixel. Put it up by 1, come on, up by 1, like that. Then we're gonna adjust the other one. It should be right on the top of the thing. Or I guess I was slightly off. I should actually technically lower it by 1. And the point is, when you measure that height, I can go to distances, and I can see here that corresponds to a pixel, or a height in pixels of 375 pixels. And then I repeat this again for a bunch of different platform heights. For example, I could do this one, and I could adjust these platform heights, and continue to get a bunch of different angles and pixel heights. And that is exactly what I did that's what I did off stream. So here you go. So that is what this data is. So here you can see exactly the same stuff. So I have the height in pixels. We have a height of the platform itself that we're measuring the angle from. And then we have the delta y, we have the angle theta, we also have, the delta x and whatnot, our y naught and our yp, because we're using Yellen. And yeah, you can see here I also calculate the angle like this, and I also calculate, oh wait, this one I'll talk about later. But yeah, you can see I calculate an angle and I have a height. And if you take a look at this diagram here, just ignore the predicted thing for now. I'll just move it for now. So we're going to, and yeah, you can see here that we have plotted the angle in degrees versus the height in pixels. And what we find out is that we have this straight line, or it looks pretty straight as far as I can tell. Yeah, it just looks pretty straight, and we consider it from an angle of pretty much 0 degrees, because 0 degrees is going to be always going to have a height of pixels of 0, so that one was pretty obvious. And then I went to a maximum height or angle of 24.136 degrees. So yeah, but because it looks like a straight line, what we can do is to actually fit a line that best accurately fits, or best accurately, matches the data. And that is what all this other stuff is about. I basically this is basically something called linear regression in statistics. So what I essentially did was I did a bunch of statistics to calculate the slope of this line. I did not include the what's it called? Y-intercept. I did not include the y-intercept because it's not really needed. We already know at 0 degrees the height of pixels is 0. So I did not include the y-intercept, and I only computed for the slope. And over here you have this number here that don't mind it too much. It just r squared. R squared is basically a number that measures how accurate the line fits your data. So these blue points are our data points, and it fits with it 99.97 percent of the data. So yeah, the closer this number is to 1, the more accurate it is. So this is pretty accurate. This is a pretty accurate measurement this is a pretty accurate way to gauge the angle theta to measure your yeah, it's pretty accurate at predicting this relationship between the angle and the height in pixels. But now that we have this relationship between a height in pixels and an angle in degrees, what we can do now is we can actually take any point, we can take a height in pixels and convert that back into an angle in degrees. Can you see where this is going? All right. So we then, from there, we can go back into our equations and whatnot. So let me do that. And now we can use that angle that we measured from a height in pixels and plug that into our formula to finally find the height of an object h. So that is all the background. That is the background needed for this study. That is it. Now, of course, I could probably talk about linear regression, but I'm pretty sure you guys probably want me to move on by now. I've been talking for an hour, and I haven't even started any experimentation. So that is the necessary background. If you want to learn more about linear regression, I do have a video. I'll show it to you guys. I have a video. I'm not sure if you've watched it. I have a video. It's... Where is it? It is specifically... Okay, where is it? This video. This video is... And this video and this video. If you want to learn more about linear regression, you can go ahead and check it out after the stream. It's not too important for this... for this whatever I'm gonna do today. The important part of the linear regression is just to get this equation of the line, but we don't really technically need to know the details for that. And yeah, so what I'm going to do is I'm going to note down some important numbers here. So for one, we have theta in degrees or whatever is equal to some height in pixels, and then it's related by some sort of constant. What is that constant? Okay, that constant I will specifically call it, okay, sorry. What I'm going to we divide this by some a number because I personally would prefer to consider the reciprocal. I'll call it gamma or something. I'll just call it gamma. And gamma is equal to, let me go back to my spreadsheet. I'll show it to you guys. So you have the spreadsheet and whoops. And this is gamma, this number here. So 21.65 653 pixels per degree. And there you go. And from there, we can now use a measurement in pixels and convert it into an angle in degrees. Voila. And then, yeah, now we have all the necessary tools to measure a height. Now, the next question is this. What should we measure? Because, well, yeah, there's a lot of things that we can do now. We can measure a lot of things. So I'm going to go back into Teyvat. We're going to go back into Teyvat, and, well, where can we, what can we suppose, what's the height of what object can we measure is the thing. Now, to narrow things down a bit, ideally we should be located somewhere, uh-oh. Okay, is the internet okay? I freaked out a bit because, you know, I don't want my internet to just die out. Please.
Navigating the world is a whole lot easier.
Is it
with
okay?
a few different
Is everything
identities to
alive?
choose from. Need me to come up with some for you?
Is everything alive? Yep, it's okay. Okay, thank gosh. Alright, alright. Thank you, Rad. Right, okay, all good on my end. Good, okay, that's good. Alright, so for one thing, we would... Oh, it's back. Ah.
Good roll.
Okay.
All right. Maybe I'll take one more
we need it to be
off and
sea level
knock
because
out
that's where
rest
the
of
radius
work once I'm
is.
feeling up to it.
Alright, so that leaves... That doesn't give us too many options. For one, it could be somewhere in Nachlan. We could go somewhere... We could be somewhere in Inazuma. We could also be in Musk Reef. What... I also ideally should... We should also ideally see if... Okay, because we also need to... I think we also might need to use a bit of... What's it called?
I got a new
The
letter from an informant.
equations I
Looks
used
like
in
the
last
situation
stream
has
to
changed again.
derive some things. So, you know what? I think it's best that we just stick with Musk Reef. Give me a second. I need to take a sip of water. Alright, okay, I'm back. Let's now head over to the thing. So... maybe that's not a ridge I can climb. Let's head over there. Come on, Yellen. You can sprint. Okay. Probably wait for my stamina to regen a bit before I start flying over the ocean, you know. Just a little safe precaution. Moose? No. There we go. Heading over. Just head over to this little area right here. Alright, so, let me change it to daytime, that way we can actually see some things. So, I'll change it to a little bit before afternoon, because the fog, there's a little bit of fog, and it clears up around the afternoon, or, like, around noon. So, yeah, you can see here it's a lot easier to see. So, there's a lot of stuff we can actually measure the height of. Granted, some of these are going to be more convenient than others. The one thing I personally... So, the one I measured all the way off in the distance... I think it's a little too far. It's hard to say anything, and yeah. So... Yeah, I mean, I think you guys could just... I watched back the live stream recording. it is so hard to see it. I'm really sorry that you guys can't see it, but I mean, if anything, you guys can come over to this spot, go just set the time to be like the noon, and then look out over the distance. You'll be able to see that there's like the shape of the island, the Yashiori Island, and then you can go in the opposite direction, and you'll end up seeing Watatsumi Island, and then you can just barely see that there's a little bit of an archway. It's hard to see it, but what's a little bit easier to see is, well, a certain ship. Right there. The Alcor. Captain Beto's ship. So, what I'm hoping to do is to see that if we measure the angle from the height of that object like this, we'll be able to accurately, or yeah, if we use some trick stuff, we'll be able to accurately predict the what's it called? We'll be able to accurately predict the actual yeah. Actually, I'm thinking about things right now, I'm sorry. Maybe instead of measuring the height, or instead of calculating the height, maybe what we should do instead is to do this backwards. We measure a height, we calculate a distance, and then we figure out a height in pixels. So we start with a height. Yeah, we start with a height. We start with a distance. We figure out that angle based on the height and distance. So we use this equation instead. I'll take that out of the. I'll take it out of this. We have tangent theta, h divided by d. Then we can go all the way and plug that in to the. We can plug and then we can calculate. Then we can calculate for HP, which is our predicted height in pixels at a distance of d. So what we're going to be doing is to predict how many pixels tall the object should appear to us at this distance. So for example, so we want to figure out how many pixels tall the Alcor is from this distance. That is what we're doing. So, yeah, let's start off. So the first thing I'm going to do is I'll right away measure the height in pixels. So what I'm going to do is try to go a little bit further away, because you never know, it just gives us a little extra distance to work with, and oops, not too far, otherwise Yellen is going to end up in the water. Come on, Yellen. There we go. Okay, just a little further. I think we're pretty close to the water surface already. And by the way, be sure to like the stream. Just helps me out in the algorithm. Be sure to like the stream. You could share it with others. The sort of thing. And also, if you're willing to support me, I do have like super thanks and whatnot, super chat, super stickers. You can see it in the around the chat box. So yeah, somebody liked. So yeah, there you go. There you go. Yeah, just don't feel obliged to do like super thanks and super chat. Don't feel obliged to do it. Just do it if you want to. All right, let's continue. Enough about that. So, I think this is a good spot. I'll just angle it slightly and try to get the arrow tip about more or less where the top of the Alcor is. Now I do have to say that because the we're dealing with large distances, this will be a little bit, there could be a bit of inaccuracy in this. So yeah, we have that, and now all we need to do now is to, I'm going to do here is to take a screenshot, just like that. So I'll take a screenshot here, or no, let me take a screenshot just a little further like that. So we're using the maximum scale. Take a screenshot. I'll go into Photo P here. And next, I'm gonna go to the Alcor. To make this a little faster, what I'm going to do is I'll also bring out children in here, so that way we can
All right, after you.
Climb up a little faster. So we just need to figure out what is the tallest point on the Alcor, or at least the tallest point that was visible. So I'll check out my screenshot here. Okay, let me bring up my desktop here. So this is the screenshot I took. We can just barely see the Alcor here. It's a little difficult to see. Or here's what I'll do. I'll go bring this into Paintal Psi. Bring this into Paintal Psi, and yeah, you're able to see it. So you have this little sail. You have the sail here, and then there's like the body. It's a little difficult to see. So this is what it genuinely kind of looks like.
Waves are as calm as always.
All right, then from there, okay, we can kind of just see that the tallest point that we can barely see is really actually the tip of the sail. So let's see in Genshin. Let me go back to Genshin and show it to you. Whoops, not that. Genshin. It should be it should be this point here, more or less, that point. So let's go climb up and go over there. So, Shilinen, do your magic. Dear gosh, she was able to climb up the whole way. I didn't even know that she would be able to. So, for whatever reason, it doesn't look like I can see this mast. So, yeah, I'm not going to include it. So we're just going to go to the tip here, right at the very top. So, this should be where we were looking at, what we were looking at earlier. Alright, so let me bring back Yellen here, because Yellen is part of the team for a moment.
Who's our target this time?
And what we're going to do is I'm going to open up the map again and put Musk Reef into view like this, and just take a screenshot. Now, what's it called? Whoops. Just give me a second here. I'm actually preparing some stuff. Oops. Where is it? Where did I put it? Okay, I'll head to my desktop here, and here we have some data from, let me go to my let me go to my YouTube channel. So what I'm going to be doing here is to actually measure the distance between those 2 points I was at, where I took the screenshots and everything. And if you want to know how to do that, I do have a video with it, and it's called How to Measure Distances with a Map. So you can watch this video if you want to know what exactly I'm doing. So, yeah. Let me bring up Paintal Psi here because I need to do a little bit of extra math here. So we have that, we have the distance, actually, the distance between the 2 points is going to be the measured length in pixels divided by rho. Now, what is rho? That is a constant that converts pixels to meters, and it depends on various factors. But luckily for me, I did something very simple. I made sure to zoom out as far as I possibly can. So that way, it's very easy for me. I already measured that. I also figured out a way to determine for any intermittent angle. So if I can do this angle in the middle, or I could do this angle, and I can also zoom in all the way. But the zoomed out one is the most convenient, as it has both the 2 positions in the same screenshot. If they're not in the same screenshot, you have to take multiple screenshots. That's just how it works. Anyway, because of that, let me open up my desktop here, show it to you. Because we're dealing with that, we actually already have this number here, 0.392 pixels per meter. You know, it's like rho 100%, rho 0%. Rho 0% simply means that you're fully zoomed out. So yeah, so we have 0.392 pixels per meter, and I'm just gonna go write that down in Paintal Psi, so that way we don't forget. Rho is going to be equal to 0.392 pixels per meter. And now all we got to do is to measure LP. So LP, well, yeah, we're going to have to do that in our image editor software. So here we are in Photopea. I have 2 screenshots, one where the player is here, and another where the player's here. Hold on, give me a second here. My mouse sensitivity feels weird. I feel like I'm... Oh gosh, give me a second. Dear gosh. Enhanced pointer precision, turn on, please. I do not know why. Okay. You know the Windows set... Okay, how many of you actually use a mouse here? You know, like... Or how many of you are on PC, or they use mouse and keyboard? Because, I don't know why. For me, I don't know why my mouse settings always constantly switch off of enhanced pointer precision, and it's annoying. I need the enhanced position. Otherwise the mouse feels like it's moving so slow. I don't know why. But yeah, we have our 2 screenshots. We have one here, and we have one here. Now, all we got to do now is to align the 2 screenshots. So I'm going to give myself a little bit of extra space here. So rather than 1920 by 1080, what I'll do is I'll probably just change that to 250 by 150. It's more than we need, but whatever, it doesn't matter. Next, I'm going to take the top layer, and all we're going to do is we're going to align the 2 screenshots. So just like this. So, oops, let me zoom out. Just zoom out like this and align the 2 screenshots. I'm making use of... hold on, what am I even aligning it correctly? Okay. I'm making use of... Wait, what is happening? Oh, there we go. That's why I was like, what the heck? Nothing is matching up. I'm being stupid, that's why. So we had to align the screenshots just like this. So now, getting just almost there, and see where it's most clear. Okay, there we go. That looks pretty lined up to me. And let's see. Looks pretty seamless, is from what I can tell. So, yeah. And now all we can do, we can raise... Oh, we don't actually want to raise the opacity. What I can do is to actually... What is the screen? I was pressing M. So, what I can do is to actually just delete this. That way we can see it see it through. And there we go. Now we have an aligned map with the two positions. And then from here, I can now measure the distance between these 2 points in pixels. Hold on, why is this not visible? There you go. I was like, what the heck is happening? So I put this right at the tip, right at this tip of this diamond shape for the arrowhead. And I'm gonna do the same over here. Put it right at the tip of this arrowhead. Maybe more or less. Yeah, we'll put it here. And now we have a distance in pixels, just like that. And now we can just, I'll tap this number. I can check the distances, and we can see here we have a height of 777 pixels and a width of 638. There we go. Now we can calculate the length of this line. So go back to Paint Psi. We can use Pythagorean theorem. So we have LP squared is equal to, what was it? I forgot what the numbers were, but it was like 777 pixels squared plus, was it 638? I'll just check in a moment. 638 pixels squared. I'll just check. 638, yep. And then from there, we can now calculate LP by taking the square root on both sides. So if you do your algebra, it's technically positive. It's technically positive, negative, but nobody considers the negative distance. So there we go. And yeah, you'll just do that. Oops. Square root 777 squared plus 638 squared, and the square root of that. So we get 1005.372 pixels. What do you know? And from here, we can now calculate a distance. So we have so our distance in meters is going to be the 1005.372 pixels. And you divide that by the 0.392 pixels per meter. And this gives us a distance of 725 meters, or just approximately 2.5 kilometers away. Does that answer make sense? Is another question though. Is that distance actually 2.5 kilometers, or am I just being stupid? So, unfortunately, this is a little bit difficult to prove, but we can do is to use something that is roughly within reason. Unfortunately, it does not look like I have any quests that are nearby. How about next story quest? Do I have any? Do I have somebody? I have not done any of the Liyue people quests. And I don't really want to start any of them. Or how many? Okay, hey chat. How many of you done Beto's story quest? Or is okay? Is no one? It's okay. Okay, because it's like my thing here is that I just want to be able to see if I can accurately give some rough estimate. Alright. Let's see. Let me see. Let me take a look at those screenshots. So did it have the chasm in the view? It did not. Okay. Okay, this is a little awkward. I think. Oh, okay. I think okay, I can get a rough idea. So in this quest, I do feel like that this distance is more or less equivalent to this one. It'll probably be off by a bit. It's okay. But the point is, it is roughly 2814 meters. So yeah, not if you discount the height differences and whatnot, and it's probably not 100% at like 100% equal in distance to this one. I think that's a pretty good, decent way to check and verify that this distance that I calculated, the 2000 or 2.564 meters, is pretty accurate. This distance is actually a little bit bigger than the one I did here. Just a bit. So I think that's a pretty decent way of checking that whatever value I measured is correct. Alright. You also have to keep in mind that there's height differences, so yeah. Anyway, enough about that. Let me go back to Painter's Sai here because we have to do some more calculations. So now that we have a distance d, we now need to know the height. So what is our height? Just rearrange this that way it's a little bit more neat. Okay. Now all we gotta do is to measure the height of Beto's ship. And what we can do is simply glide downward. So I'll do v glide. And the falling speed of gliding, I also have that measurement with me. I just need to pick it out from my folders. Where is it? Where did I put that? Measuring distance. There it is. Player speed data. The falling speed is 1.9. Yeah, more or less 1.9 meters per second. So all we got to do is to simply all we got to do is to simply, what's it called, measure a, we simply do like VG times some multiplied by some time, and we'll measure that time by recording our screen and then opening it in DaVinci Resolve, and then there we go, we'll have a height. So 1.9 meters per second. We don't need to necessarily write it down there. So, my computer's gonna scream, but what I'm going to do here is to simply glide down to the water. So, I'll start recording. Or wait, I need to make sure I have Genshin open, that way I can actually see. So, yeah, I'll start recording. Like this. And... oh, nope, messed it up. I should not jump. I need to just fall off and open the wind glider. So that's all I need to do. So, just like that. Might have lost a little bit of height there, but like that extra like frame or two of not gliding doesn't matter. So I'm just gonna wait until Traveler hits the water. How you guys been, by the way? Doing fine? We're almost coming up to, and we're about an hour and 40 minutes in. So how you guys are feeling? Just want to know. And there we go. We touch the water, and from there we can stop recording. Now, all I gotta do is to go into DaVinci Resolve. So, yeah, while that's happening, it probably, yeah, just wait. It's gonna take a bit to load, so just give me a moment. And yeah, I'll go over to DaVinci Resolve. So, Rad says he's doing good. That's nice. That's nice. Good to know. Okay, DaVinci Resolve is still loading, so again, give it some time. Okay, still loading. Okay, DaVinci Resolve, here we go. Here we are, now we're in DaVinci Resolve. Now all I gotta do is to find that clip, and we'll be able to measure the height. So we are DaVinci Resolve. I need to bring in the clip. That's, what did I just click? Okay. Here we are. This clip. Change the frame rate. So now it's inside. Put that here. And we don't need the audio, so we can just mute it. And here we go. Now all we gotta do is to consider the time frame when the player simply is hanging off the edge. So, oops. Let's see the moment that Traveler opens his wind glider. Right on this frame. So there we go. Right on that frame. And we delete everything else because we don't need anything else. And we're just gonna zoom on ahead and go all the way to the point where the wind glider disappeared, because Traveler is now touching the water. There you go, touching the water. Frame 0. So there we go. And now the number of frames is 1,791 frames. So we go back to Paint Tool SAI, 1,791 frames. So 1791 frames. Sorry, I keep repeating myself because I don't want to forget it. However, we got a little bit of a problem, of course. We have a unit of frames, but we need to convert that to seconds. But luckily for us, that conversion is very simple. I'm running my game at 60 frames per second. So therefore, this should be 60 frames per second. See what I did here? And there we go. Now we have a height. So 1.9 multiplied by 1791 divided by 60. And we get a height of about 56.715 meters. That's more or less how tall the sails are from the water. Alright, with that, we now have everything we need to calculate the theoretical height in pixels. So, from all the way in Musk Reef. So, we just plug it into this tangent formula. So, tangent theta is going to be equal to the opposite. That will be the height divided by the distance. There we go. height divided by distance. And with that, we can use that to calculate our angle theta, and that will be in degrees. We simply plug these two numbers in, and let's see what it gives us. So, take my calculator, inverse tangent. H is 56715. The distance is 2564725. There we go. And we do the arc tangent or inverse tangent of that. And that gives us an angle of 1.26. I'll give myself some extra decimal points because it is going to be a little sensitive. The date, it is going to be more or less. It's going to be a little sensitive. So we got 1.2668 degrees. And now we can finally use our relationship at the very top here to calculate the theoretical height in pixels. So the theoretical height in pixels, HP, is going to be equal to, well, our gamma was 21, or what was it? 21.653. 653 degree, or pixels per degree. And lastly, we can put in our degrees here, so 1.2668 degrees. And this will give us a height in pixels, an estimated, a guessed height of pixels in, let's see, 668, 27.43. So we could expect more or less about 27 or 28 pixels tall. Of course, it probably might be a little bit different. Who knows? This is our estimation. So let's now go into Photopea. And what I'm going to do is to bring up the screenshot I took earlier. So here it is. I said, here it is. There it is. Okay, this is the screenshot I took earlier. All we gotta do is to essentially consider the number of pixels tall the Alcor is. So you can just barely see it. We also have to match it up with the horizon. So more or less here, I think that's what it is. Is that it? Or is it one lower? I cannot tell. I actually can't see it too well. I'll mark this as the lower. So this is the lower. Horizon, more or less. Or wait, what? I'm confused. Wait, hold on, what? Okay, never mind. You know what? Okay. So this line here is more or less the horizon. I can barely see the horizon, but is it the horizon? Ah, gosh, I can't tell if it's like a pixel lower or something. Does that look right? Does that look right? Is it lower, though? I feel like it's fine, though. Yeah, I think I'll go with that. Okay. Moment of truth. Let's see. 28 pixels. 27, 28 pixels. Right on the money. Right on the money. 28 or 26 pixels. What did I tell you? What did I tell? Yeah, there we go. We calculated the theoretical height. We measured. So our actual measured, I'll just call it HP star. This is the actual 28 pixels. We did it. We accurately measured, very accurately measured the angle, the height in pixels and whatnot. Now, here's the thing. Here's what we need to now figure out. All of this basically says, we've been doing all this, but, like, how does this actually even prove or disprove that if Teyvat has a radius? here's the problem. Okay. What I'm going to do is okay, I'm going to use the math that I have here from my previous live stream. It's okay. And it might be a little confusing, so, or I don't know. There's not too much to know about it. Let me just try to find the angles and whatnot. So, okay. So, I basically derived this formula last live stream, and we can make use of it in this stream. So, here it is. We're going to make use of this live stream. Or, you make use of this. You can also see here that we have an angle theta here. What I'm going to see is what angle should we expect? We also have another formula, which is that S is equal to theta R. Or actually, wait, no. We don't use this formula. Sorry, my bad. We don't use this formula. This formula is for something else. It's actually related to this. So ignore that top one. What we're going to use is this formula here. This S here is the arc length along a circle. So it's a distance along a circle. And then we also have the radius. And we're going to test what happens when we set R is equal to 1778 kilometers. Our distance from the Alcor to from the Alcor to Musk Reef is, what was it? 256. What was it? 2564.725 meters. And now what we can do here is plug this into our angle theta. Okay. Oh, wait, we do need this formula. I'm sorry. Okay, we do need this formula. I'm stupid. Yeah. So we have this angle theta. Okay, just don't mind me. I'm simultaneously thinking about things because I'm kind of doing this off the top of my head. I'm sorry. So theta is also equal to S divided by R, and S is going to be equal to 2564.725 meters, and the bottom is 1778 kilometers. Now we can't just divide meters and kilometers. They have to be the same units. So what I'm going to do is to convert meters to kilometers, and there are 1,000 meters for every kilometer. So you can see here, you can cancel out the meters like that, and we'll be left with kilometers divided by kilometers. Now, there's technically something a little more specific here. It's kilometers per radian, but nobody actually ever includes that. So theta, it's important, but you do need to know that it is in radians and not degrees, this angle. I also should tell you that this angle theta is different from this angle theta. These are not the same angles of... These are not the same thetas. Maybe I should use a different symbol just to make that clear. I'll call it alpha or something. I'll just call it alpha. That way we don't get confused. So alpha is just the angle from the center of the planet of Teyvat to between the two positions. So there we go. That way we don't get confused. So 25 divided by 1778 divided by 1,000. And we get a really tiny number. This angle is not the same as theta. It's going to be wow, this is a really tiny number. I might as well use scientific notation for it. 1.42 times 10 raised to the minus 3 radians. Now, I explained the difference between radians and degrees, but there are conversions for it. So what we can do now is convert a radian to degrees. So we have that there are pi radians for every 180 degrees. And this is going to be equal to, take that number, multiply it by 180, divide that by pi, and we get a really tiny angle. This angle is 0.08226 degrees. Now, we take that angle alpha and plug that here. Sorry, I'm thinking. Okay, I'll just keep going. So from here, what we can do is solve for h. This h, I do have to keep in mind that this h is a bit different from the other h I used in this formula. This formula is different. This h is different than this. Dear gosh, this is really awkward. I should redraw this. Okay, let me redraw the diagrams and everything. That way we don't get confused with everything. Okay, I'll put this here and I'll redraw the diagrams. That way we don't get lost with all the common symbols. So let's just redraw everything. So we have some angle, we have some theta. Then we have a height, an object with some sort of height. In this case, it's going to be the alcor. And where some angle, I'll just pick an arbitrary point. We'll call it S. Okay. We're not gonna call it S. Sorry, I'm thinking. Okay, whatever the case is, this angle is going to be alpha. And this distance from the whatever object we're looking at and the player is going to be S. It's technically the same as D I measured earlier. And then we have our radius R. Oh wait, no, the H is actually the same H as that. Radius R. Oh no, wait, no. I'm stupid. It's not the same. Okay. I'm sorry if things are a little confusing here because I'm a little I'm coming up with this on the spot, so forgive me if if what I'm doing is a little confusing. I'll just call this Y. YL, or I'll call it HL. Because what we're essentially doing is that if you pretend that this is a tangent line of some kind, and then this is the point. The point of this is that. Okay, sorry. Okay, I'm really sorry. There's a lot of stuff going through my head, but the point is that this equation here has an HL instead of just an H. Okay, HL. Then we can solve for HL. you multiply both sides by, okay. You multiply both sides by RHL cosine alpha is equal to R. Then you divide both sides by cosine alpha. Get R cosine alpha. Then you get H minus R like that. You simply factor out the R, get 1 minus like this, multiply like that. Okay. Divide, subtract R, factor out. Yep, that looks correct. So we get this. Okay. Okay, yeah, okay. I think... Or, give me a second. Okay, I feel like... I need to think here for a second. Okay. Let me just continue with this. So I can plug in the values of R and cosine alpha. So you get that HL is equal to, let's see, 1078. You divide that by 1,000, or not divide, but you multiply by 1,000 to get distance in meters. And then you do 1 divided by cosine of alpha, which is in degrees, and we get a lost height of 8, or okay, about 8.5 more or less, because rounding. Okay, so what exactly is this number I calculated? So if we kind of imagine a curved surface, more or less, you can imagine that if you compared it to a flat surface, yeah, we have a flat, if you imagine we have a flat surface here. And we have an object that is that has a height of h. I'll just copy this, put it there, make it partially visible. I am exaggerating this curvature, by the way, or maybe I should not exaggerate it too much because I might make things a little awkward. So, if you're on a flat surface, you would imagine that this will take up a certain angle in your field of view. Let's call that theta, or I'll call it theta flat or something, or theta f. But if you imagine that same object, maybe let me make sure I get the height more or less the same, so I'll just angle it more, it's approximately like so, and at the same distance, more or less. More or less the same height. So it should be the same height, like this. But because this is now below the surface, you essentially only see a smaller angle theta round or something, and you lose some height in that process, which is what I'm calling HL. So that is exactly what I'm doing here. So if that is the case, if we do lose a meter, or about 1.85 meters, how much will that impact the angle we see? That is what I'm trying to show here. So hopefully that makes sense. So how much of theta, or how much of a difference of theta does it make? I have a feeling it's not going to be too much because it's only a meter. And, well, the actual height of the outcore that we measured is this. So let me go ahead and draw this out. Or not draw it out. I'm going to bring in H here. And I'll call H prime, or I'll call it HR. Why not? I'll call it HR. That is this height here that we can see here. That is remaining above the surface. I'll call that to be HR. So HR is simply the actual height minus the lost height, like that. And then so what we'll get is simply subtract the two. So 56.715 minus 1.85. We get 5 or 8.865 meters. So that is, we'll use this now, and I think we'll make use of our tangent function, tangent theta, and that is equal to, the opposite will be the height, but we're going to use HR this time. And then we'll divide that by s, which is the distance between the 2 points. And that will give us our angle theta for a radius Teyvat. Let's see. I don't actually know if this will prove or disprove, or if I'm also just going to be just as clueless as last time. Who knows? So we'll take those numbers and we'll run with them. Let's see. Let us see. As soon as I actually input the numbers, we'll get an angle of 1.225 degrees. Oh gosh, this is gonna be close. There's only like a very small difference here, so it might actually be more or less the same problem. Okay, let's see. We had that, what was the equation? It was that our height in pixels for a round Teyvat is going to be equal to gamma times theta, and gamma was equal to, let me just copy this. Copy that, paste it here. Oops. Paste it here, and then just change this. 225 degrees, and well, moment of truth. We'll see if this even proves or disproves anything. Moment of truth. You know what? Here, I'll run a poll. No, mind. What do you guys think? What do you guys think will happen? Do you think that the height is gonna be the same, or what? Yeah, just whatever. You do you guys. What do you guys think? Is the height gonna be, the height in pixels gonna be about the same, 28, or is it gonna be less? Is it, or why not? I already put the numbers on screen, so I mean, you guys could technically just calculate it. But okay, I did calculate it. What do you guys think? What do you think is gonna happen? Will it be just enough? Will it be inaccurate? Is it gonna be accurate? Or is there gonna be or what do you guys think? It's not gonna be conclusive. Are they gonna be the same, just different as? Is it gonna be 28 basically? Is it gonna be close to 28 or not? Well, I mean, I don't know. I'll just wait for you guys. I can actually close DaVinci Resolve. That way my computer does not explode. I'll just wait for you guys. You know, I could really just insert an ad here and that would be really funny. You know what? That does sound funny. Let's do it. Yeah, I do. By the way, because something I don't know if I don't know if people actually know you can insert ads during a live stream. I try not. I'm not gonna go overboard with the ads. I promise. Because I know I myself as a person who watches a lot of YouTube knows how annoying ads can be. So I try to do them during points of you know, where I'm not doing anything, but in between session or like in between moments where I'm like I'm gonna take a sip of water, that sort of thing, or I'm transitioning to other things. That's what I say. So Rad says close to 28. I would say. So I'm guessing that's I'm guessing that's what everyone else is gonna say. So let's just go with that. The answer was 26.525 degrees. Now here's the thing. It is slightly off, but the thing is it far enough away from the thing? Because, you know, that's 26. The actual thing we measured was 28 degrees. Or not degrees, sorry, I'm stupid. That's not degrees, that should be in pixels. So, yeah, I'll just gather all the numbers. I'll put them all together. So we have HP. We're going to, here we'll have flat. Well, more or less. More or less flat. And we have curved. Curved and, well, yeah, we'll have a height and height of pixels. We got, what was it, 27.43. Oh, not meters, that should be in pixels. And the other one was 26.525. The actual distance that or the actual height that we measured was 28 pixels. Now, here's the thing. This could be off by 1 pixel. It could be 27 pixels. It could be 29 pixels. So, these two are very close. These two are very close. Do we know... Okay. Is it a significant enough difference? That is the question. Is it a significant enough difference to say that the radius is wrong? That's the thing. I'll just take a sip of water. Stay hydrated, by the way. I'll just calculate the percent error, that way we can see. So the percent error. I have a percent error. Simply put, that is going to be 27, or what? We'll take like 28 minus 2743 divided by. The percent error is like is about more or less 2.36%. And then we have the other one, which is 26.52 insert 5. That will be 5.268% error. It's not far off. They are not far off from each other. Okay. I'm gonna go into the game. And I'm gonna try something. I don't... the problem is when you're in Inazuma, it looks like there's a fog. So you can't really see anything. But we are a bit limited by how far away we could be from this thing. And because there's not too many places where you could see it from this side, because it's getting blocked by this cliff side. I mean, I could take the wave ride. I have the wave rider over there. I could just take a ride and go over here, more or less. It'll give us a little bit more distance, but I don't know. Is that significant enough? I don't know if statistics, I'm not sure if there's anything I could do in statistics that can necessarily prove it, though. I mean, it is not far off, I'll give it that. Okay. Okay. What do you think? Do you think I should, try again, but with a different object? Or maybe I can... I'll do something different. What I'll do is... What I could do instead is to consider the height of a different object. To me, it doesn't look significant enough, but that's just me. Okay, yeah, that's what Rat says. Do you want to try to do something... do you want to try to do, like... Okay. Yeah, do you want to try to measure something else, basically? Like, because my problem with the Alcor is that it's not too far away. So well, yeah. We know that we only lose a meter of height from where we are. We only lose a meter of height. Or about 2 meters, or 1.8. We lose about 1.8 meters from a distance of, what was it? 2.5 kilometers. So the distance from Musk Reef to the Alcor only gives a height discrepancy of 1.8 meters. Maybe what we should instead do is to consider something much farther away, where the height difference, or the height, might be greater. Do you think I should You think, alright, maybe we should. There's a lot of stuff in Inazuma we could use. The problem is, can we even see it, is the thing. Because I could go to all the way to Nachinan, and we should be able to potentially see something. Okay, here we are in Nachinan. And I will simply indwell and try and see if we can get a view of Inazuma. The problem I might have is that Inazuma might not be visible. In the sense that, well, you know, it would be a horrible decision on Hoyo's part if they would render the entire map at once. That would be an awful decision. Because, well, that would absolutely tank your performance. So, them being smart people, they actually, I mean, you know, they don't render the entire map whenever you, for example, you can't see a lot, I mean, from here, you probably won't be able to see something all the way in Mondstadt. You're probably not going to be able to see Mondstadt, so so Mondstadt itself is not being rendered. We can see some stuff far out in the distance. Okay, that's cool. But the one thing we want to know is if we can see something from Inazuma. I mean, it doesn't even have to be Inazuma. It's just that I need to know the height, its height off the ground. The question is Inazuma even rendered from here? That's the question. Because am I too far? Or would for Inazuma to even be rendered? And what even is that? I think that's the desert, so it is what it is. Let's just swim. Try and see if we can get a view of Inazuma. Or if we can get just the height of something far off in the distance. Okay, we're running into the border of the Okay, Inazuma is in this direction. Okay, I don't think we're gonna be able to see Inazuma from here. Is that the desert? Yeah, I think that's the desert. I don't think we're gonna be able to see something here. Can I see Ochkanatlan from here? Where's Ochkanatlan? Is it in the way of... Oh, it's kind of in the way. Okay, let's see. Can we see it from here? Where is Ochkanatlan? Let me just make a pin, that way we can see it, and I'll... Did I just place a pin in it? What? Where's the pin? Oh, I need to zoom in. Blah. Okay, then navigate. And that way we can see what direction it should be. So it should be in that direction, but I think this mountain is in my way, so I'll go ahead and climb up.
The wind rises. Squall and fury.
That is a volcano. And there's Ochkanatlan. A bit of a problem I have though is that I can't really tell if yeah, I can't really tell if how high I am off the. Yeah, Ideally, I would like it to be close to sea level is the thing. So that is a little awkward. Notland, though, is a little bit visible, but it's quite far. This is kind of why I'm using stuff in Inazuma, because it's kind of easy to see, and also Musgrave just in general is like a really, you can actually just see a lot from Musgrave.
This blinding sunlight is such a pain.
Okay, Ariane, I'll bring back Farina. Forgive me here if I'm just brainstorming at the moment because again, it's a little awkward. You have to deal with these things. I'm just jumping because I think it looks adorable that it looks like the character is skipping. Okay, so what can we see from here? We can see that. We cannot see. Unfortunately, I was hoping that we would be able to see this little tiny island above, you know, from Serai Island. I was hoping to be able to see it from here, but it doesn't look like you can. Yeah, I'm not seeing it, so that's unfortunate. We can see the shrine from here, but that would be quite a bit of a thing to measure the height of, I will say. I do have an idea for how we can measure its height without having to glide all the way down. But it also I do also have to keep in mind like how exactly I'm going to measure the height from. Where on this mountain I'm going to be measuring the height from. So yeah, because I have to consider what position to put my crosshair. You can see the floating island near the stone forest in Liyue. That floating island? Wait, you could see the Serai Island all the way in the stone forest of Liyue. Stone forest. I'm pretty sure this is the stone forest, right? I'll just teleport and see where it goes. No, or what? Oh, I'm stupid. Okay. I know what you were talking about. Okay, I'm sorry. The floating island. Okay, the floating island. And the one that's like at the top. Near. Oh wait, it's near Beto's ship. You could see that floating island from near Stone Forest in Liyue. Okay, let me just go back to where I was. Okay. By the way, thanks Rad for helping me out. Let me just floating island in the distance. Floating island? What floating island?
Smile.
Sorry. What? I mean, there's the Jade Chamber. But it's not too far. It's not that far away from it. The Jade Chamber is not, I think it's a little close to where the The floating island in Sarai Island. The floating island in Sarai from Stone Forest. Oh, I'm stupid. This is Stone Forest. Ah, I'm dumb. Okay. Let me think where. Okay, we want to go somewhere near close to the sea level, so I'll just go there. Okay. It is a little closer, so yeah.
I better find a way to keep my camera dry.
Are you kidding me? It is raining. Because it is raining, I cannot see because there's fog. Look at that. Fog. It's foggy. Okay. Here I am hoping please change.
To exchange pleasantries. It's rather pathetic to force a conversation just to occupy silence.
Okay, is it back? Yeah, I think it looks like it's back. Oh no. No! Even Genshin's given up on me. Okay. Alright, let's go back. Let's go to this teleporter. And this time... Okay, yeah, this is actually a pretty nice place. Now we're gonna try to find a far away enough distance. Can we see it from Yaoguangshou? Can we see it? Or is it too far? Maybe it's too far.
There you are, eavesdropper.
Behold!
Bye. Maybe it's too far. It might not be rendered anymore.
Quit following me.
Yeah, the thing is kind of in the way. So I can't tell if...
Squall and fury.
But it should be somewhere in that direction if I'm not mistaken. Let me also just make sure I'm looking at the right place. So I'll put a pin there, that way I can navigate. Okay, yeah, I cannot see it. I can't see it. So maybe I do need to consider this. So that, to me, so this is a pretty good distance. So let me see if I can, how far away I can get without it disappearing. Behind stuff, that is. Alright, is this stream back? Dear gosh. My internet just exploded or something. Sorry about it. Stream died for a bit. Okay, I think it is. That will be good. I'm just entering the game, so I'll go ahead and bring that back. Alright. Apologize for that. That was annoying. Alright, anyway, so here I am again. We will be... Okay, Sarai Island is still visible, just that it's a little far away. And now it's behind that thing, that spear. Let's go over here. All the way over there, okay. Sarai Island should be... Okay, let me navigate to it because that way I can actually see where it is. Navigate. Is it visible?
The wind rises.
There it is. Can I see it from Liyue Harbor? That is. Because I'm trying to get as far away as I can from it. So where is it? We cannot see it from Liyue. Or at least
Swollen fury.
not. Okay, let me move a little bit closer and see if I can find a position. Okay, can I see it? I don't think we can see it. Okay, I think it's too far. The last area I can think of, or you know what? I think that. Let's go over here. Okay, just a little further out and head in this direction. We can't see it at the moment. Let's see.
The wind rises.
We still cannot see it. When is it going to pop up into view? Alright, doesn't... Oh, wait. What's that? Is that it? Is that it? I think, okay, I think we can see it. You can just barely see it. Okay, let's try and see what happens. Oh, it's starting to fade out. It fades in. Okay, yeah, it's like bordering on the edge of not being able to see it. So let me zoom in for you guys, that way you can see it. You can zoom in if I move just ever so slightly forward. Oh wait, maybe there was a cloud in the way. Or yeah, as you can see, as I move forward and backward, you can actually, it's very difficult to see. Maybe it might be hard to see on stream, but it actually is it's going in and out of our render distance. So yeah, we can see Sarai Island all the way from over here. It is very far and bordering on the edge of the farthest we can see, which is pretty perfect in my opinion. So let's go ahead and just let's go ahead and try it out.
Let's go get ourselves some.
So let's try to get really deep into the water. Oops, not too deep, otherwise Yelen's gonna start swimming. Not too deep, otherwise Yelen is gonna start swimming, as I said. Little... Okay, maybe more or less about here. Yeah, I think this is good enough. Alright, so I'm gonna angle... Okay, Yelen... Oh, come on. Maybe Yelen's not the best choice for this because of... How much into the water is she? Okay, pretty deep in the water. Okay, I think that's good enough. So, we just gotta angle up a bit. Oh, this is a little awkward with her little thing. Let me do this. Don't want to have it too... Oh gosh, Yelen. Maybe Yelen isn't the best choice for this. Change of plans. Okay, we're not gonna... Oh, sorry, Yellen. Tall female archer. Tall female and archer. Because... Or... Do we need that to necessarily be a... Yeah, I think I'll just use Sarah.
Let's do
We already
this.
have Sarah. So... I think that's a good enough position. Okay. We can barely see it. Let me change the time of day. Maybe it'll be more visible. Okay, here we go. We have the horizon like that, more or less. We're going to go just angle our crosshair just a little bit upward. More or less. Alright, take a screenshot, and now we're going to open up the map. What we have to do is to now, what I'm going to do is to simply take a bunch of screenshots. Now we're going to zoom out all the way as far as we can. And this is going to be a little difficult because Inazuma is off the coast. So we need... Okay, we have a reference here. We have this statue of the Seven, and we can see our character player here. So I'll go ahead and take a screenshot of this. Then I'll go ahead let me go ahead and hide this. All right, then I'll paste that into Photopea. We'll adjust things later. And then I'll move the camera and... Okay, so we can have both these two in view. So, yeah. With that, we can now teleport all the way to Serai Island. Let me also open up the screenshot. And teleport over there. So, one thing I'm not too sure about is if the island is tilted. The island, I think it might actually be a little tilted, so... Oh yeah, it is. Wow. It is tilted. So, because it is tilted... Dear gosh. Because it is tilted, okay, I'm trying to look at my reference on my screenshot. So, it looks pretty flat from the perspective I was seeing. Let me try and find out where I was. I was just more or less about here, so I'll also put a pin down and navigate to it so I can get an idea of what view. Okay, we were looking at it like this. So, I think what I'll do is I'll just measure height from here. Now, how exactly am I going to do that? Or actually first, how exactly am I going to do... Okay, give me a second here. I need to take off my headphones. Also, give me a second. I'll be right back. I just need to do something really quickly, and I'll just come back. So, yeah. Alright, hello everyone. Sorry about the wait. I am back. So, it's been, oh, okay, wow, it's been 3 hours. Okay. Yeah, okay, we're back. Here I am. And, okay. How's everybody doing? Doing okay? Doing alright? Don't want to make it too loud. Okay. Let's see. Okay, yep, okay. Everything's resumed. And now, oh, what Rad says welcome back. Thank you. Alright. I have an idea, actually. And what I'm going to do, I'm just gonna, okay, Rad says he's doing good. That's nice, that's nice. Alright. What I have an idea for is that I believe that these commissions, we navigate to them, they should tell, okay, they do tell us the distance to it. And what's nice about this commission in particular is that it's really close to the sea level. So we can actually calculate the height just from this. Let me back up a bit, that way I'm outside the range. Yeah, it's pretty much at sea level. So we can, what I can do is I'll simply I'll use the navigation and see I have a height, and so I'm currently 600 or so meters away. So I'm just gonna go to the tip right here. Like more or less here. Then I'll just have it right in view or something. So 572 is... Okay, 572 seems to be the distance. So yeah, it is all the way down there. And what we can do is, because in... Okay, let me bring you to Painto side, that way I can actually explain a bit of the math. Of course, so we have... So in Painto side, where we have our distance... Currently, we know the distance, I'll just call it... We have some sort of distance away from it, which I'll call it R. And, well, I can measure the horizontal distance, which I'll just call Rx. And then from there, well, by Pythagorean theorem, R squared is equal to Rx squared, and I'll call this Ry. So we can measure Ry squared.
To strike your foe
And,
takes
well,
unity
yeah,
between
Ry squared
mind,
is
arrow,
simply
and
just
bow.
some algebra. R squared minus R squared divided by X. There you go. So, basic algebra. Just use Pythagorean theorem. So, I'll start a new page for this one. We have a height, H. So we're figuring out the height H. And I'll just simply say, what am I gonna use to notate this? I'll use, you know what, I'll just use S. Or should I use S? It honestly doesn't matter what letter
The duty of a
what
Tengu
letter should I
warrior
use?
is to watch over the mountains and forests.
Dear gosh, I don't
while
know
that
what
of the
letter to
Kujo
use.
clan is
so
to
many,
guard
so many
Inazuma.
letters.
These two
Because
are
I can't.
of the same ilk.
I'm using D for distance. I'm using. You know what? I'll use L. So L was 572 meters. Now, we also. Oh wait, nah, not L. Maybe I'll use a different. Maybe I'll use. My gosh, I cannot think of a letter.
To manifest
use Z.
eternity per the almighty
I'll use
Shogun's
Z.
will.
Alright,
That is
Z
what I
will be
aspire to.
our quest distance indicator, so if you want to think about the triangle, it's going to be like this. Z is like this, and then we have H, and then I'll call this ZX. So ZX, we have to measure that using our distance formula, which we'll have to measure Z in pixels, or ZXP in pixels. And then we
To
divide
strike your
that by a
foe
row.
takes unity between mind, arrow, and bow.
Okay, give me a second. I need to... Okay, Sarah. Quiet for a bit. Alright, so yeah, we can use our we can measure the distance with using the map, and then there we go, we can calculate a height. So let's go ahead and let me bring you back to Genshin. So here we are in Genshin. All we got to do is to have these two in sight. Now, yeah, okay. So, we just need to have both of the 2 points in sight. I can either go zoomed in or I can zoom out all the way. So it's a little awkward because it's not exactly... I'm lazy to do... Okay, I'm a little lazy to have to do, like, interpolation, so I'll just... Even though we're, you know, it's not the optimal distance, I'll just zoom out. Because, if I don't, you know, if I use a middle intermediate thing, I have to do a bit more calculation, I have to do a bit more measurements, and it just gets a... You know what? Fine, okay. Or, should I? Should I? It's more convenient to just use the top or the bottom one. The one in the middle requires like a few more measurements, but it's not too complicated. It's just that it's a little bit more hassle. I prefer to use either the zoomed out or the fully zoomed in or the fully zoomed out. I'll just use the fully zoomed out, that way it's not too annoying for me. I can just calculate it pretty fast. Okay, so I'll go to Photo P. Here we are in Photo P. And here is the new thing. So, what the heck is this? Okay, that's what it is. I just realized I could actually... Okay, let me delete this screenshot. What I'll do is put the... Okay, I'm gonna go back to... Sorry, I need to go back to Genshin. That way you guys can see what I'm doing. I'm gonna have this statue of the 7 present, and with that, I can now actually combine it with the other map I've actually already taken a screenshot with. So there you go. Paste that there. And all we got to do is to change the size of our canvas. I changed it to Photo P, right? Yeah, I did. Change the size of our canvas. Probably make it a lot taller and wider. So let's go with 4,000. And maybe we'll go with 3,000 on the height. There we go. Make it just a lot bigger. That way we can fit everything. So, we're going to do the same thing. Match up the maps. Change the... Okay, I need to make it as big as I thought I did. Or, let's move this around a bit. Let's just move it like that. That way we can take up some more space. And all we got to do is to... Okay, we can see the statue of the 7 all the way there. Right there, yep. So, good, it's not getting cut off. And all we got to do is align it. So, we're going to align the two. Ooh, looks like we got 2 positions where it looks like it matches pretty nicely. Let's see if how this one looks. This one looks decent. What about the other one? I think this one matches a little better. Just a bit. I'm looking at the docks here, but I mean, there's also other things. Let's zoom out a bit. Okay, so I think it's good enough. We can now set that to 100 because we don't really need to necessarily... Yeah. Okay, we have a little thing on the top. Yeah, I can see that. All right, so with just these 2 screenshots, we can get the height and the distance. So here we go. We'll... I should actually, let me go ahead and save this. Okay. Now, what we have to do here is we're going to measure the height by first measuring the distance between this point and that point. And we could do that simply by drawing a line between the two. Okay, so we can roughly pinpoint the center of that with that point. And now we have to find the center of this one. It's going to be a little tricky, I think. Actually, might not be. We just have to align it with that. We can align it here and here. And we can align it with vertically. So let's see. It's more or less in this position. I'm using this pixel here and this pixel here to align it. More or less. Does that look about centered? I think I want to move it just a bit to the right. But at this, is that right? How does it look? Is it at the center? I think it's at the center. Okay, now we measure the distance. So there we go. Distance 199 and 24. So here we go. Paint tool psi 199 and so we'll get square root of 199 squared. And what was the other one? The other one was 24. Okay, 24 squared, and that will be in pixels. Then again, since we're fully zoomed out, we can use row 0%, which is 0.392 pixels per meter. And now we'll have, excuse me, move. There we go, like this. Let me make that a little nicer. So we have ZX. That will be the I already know, we'll call it ZD. ZD, because that makes more sense in my mind. I don't know why. ZD, and then we can calculate the height with once we have ZD. Because we have Z, we have ZD, and we have H, use Pythagorean theorem. Okay, ZD will be equal to, or actually let's just condense it up here. That way we have more space. And I bring out my calculator. Square root of 199 squared plus 24 squared, divide that by 0.392. We get more or less 511.332 meters. Now let's calculate the height. So we have 572 meters given by the quest navigation and 51132. So 57, or actually, yeah, whatever the case is, you just plug in these numbers into this formula, and then you take the square root of them, and you'll get H. So what is the height of Sarai Island? The height that Sarai Island is let's see, square root 572 squared. Don't forget the squared. Minus 155, or let me just take the actual value itself. Squared. 200. Okay, wow, that is. Did I do that correctly? 256.367 meters. Wow, that's actually pretty high off. That's pretty high off the ground.
Duty
I mean, it makes sense.
of a Tengu warrior is to watch over
Does that make
mountains
sense?
and forth.
All right. Does that make sense though? Is the question. Well, one thing we can do to test this, but it will require the unfortunate participation of a certain person, of somebody, to die, because they will have to fall very high off the ground. So something I've measured in my Measuring Gravity series is that the gravity of Teyvat for falling is 20.4 meters per second squared, and the terminal velocity is about, what was it? Was it 30? I think it was 30 meters per second. Then, with that, let me check my terminal velocity and gravity calculations. Terminal velocity reevaluation. So when you calculate the terminal velocity, conclusion. Look at my conclusions. No. Kinematic. Okay, so there are some equations that I need to write down here. So we have Tm. Tm is going to be equal to Vmax, I think. Yeah, Vmax divided by G. And then we have that H is equal to V, or what was it? Vmax times, let me find out where it was. Vmax, where is it? Okay, I know it, I put it somewhere. Vmax, and then we have, oh, come on. Oh, sorry for making the screen looking weird. I am simultaneously looking at two things at once. So, yeah, let me put that back to normal. Sorry, guys. So we have T minus Tm divided by 2, I believe. I believe that's what it was. And that's because we know we're going to hit the terminal velocity. You more or less hit the terminal velocity from heights greater than about like 20 meters or so. More than 20 meters or something. I forgot what the exact height was. You can calculate it with this. But the point is, if this thing is truly 256 meters off the ground, we will definitely be hitting this terminal velocity, and this is the equation to determine the height. So if we can plug in our height here, our max velocity here, and Tm into this, and then we can solve for how long it takes to hit the ground. And I'm not going to make this extremely accurate because all I just need to do is get a rough estimate and just check if this is within a ballpark of what I need. So this is just a quick check. I'm not trying to be 100% accurate. So otherwise I would have just used this method to calculate the thing in the first place. So let me go back into... Oh, wait, should I use
All that of the
DaVinci Resolve?
Cujo clan is to guard.
One thing I am a little concerned about is I don't think the water... I don't know if the water... wait, I don't know if the water is even still there anymore.
These two are of the same ilk.
Oh gosh, this is actually a little awkward. Well, I guess I could just fall down and hit the coast, right? Yeah, I could do that. And by the way, again, oops, I should probably unpin that. I will be sure to, you know, if you enjoyed the stream so far, be sure to like. It's always a helpful reminder. Some people forget. I personally also forget. Sometimes I'll be like just watching and enjoying the thing, but I'll forget to leave a like, and then I'll feel bad to the YouTuber that I didn't. Sometimes I feel bad. Anyway, enough about that. Where was I? Right. Estimation. Let me just fall and see where this goes. So if I fall down, where will this bring me? Will this bring me to somewhere roughly around sea level? Yeah, I think that's pretty close. I think that's pretty close to sea level, so we can use that as a rough estimation. Who shall be our sacrifice? All right, guys. Okay, hello, guys. We have a crew. We have a lot of people to choose from. Who shall be our sacrifice? Who shall we sacrifice because they're gonna hit the ground? I'll also, or yeah, just. Who do you want to sacrifice? Because there's a lot of people you can suggest people that you can throw off the cliff because they're gonna hit the ground hard. Let's just say that. I'll go back to Paint Osai here because I need to actually calculate the thing. So first of all, so not Gumballer says no clue, and Lisa says, or Brad says Lisa. Not Gumballer. It honestly doesn't matter who we choose. Is there somebody you just want to throw off a cliff? That's all it is. Which character do you want to throw off a cliff? It's nothing scientific. It's just for the lulz. Okay, so we need to solve for time, simply put. So right now we just have Lisa. Do you feel like you want to throw anyone off the cliff, Gumballer? Or is there, or you don't want, or is it you don't want to see somebody die? Well, then we add TM, but TM is also equal to Vmax. Divide that by G, and you divide that by 2. And I think that algebra. Also, why is there no water? Ah, it's because of a certain quest thing. If you do, I think if you do a certain puzzle, there would be no. Okay, Nilu. Oh. Sorry, Gumballer, I don't have Nilu. Sorry. Yeah, is there a quest which I forgot to do? Or I'm not sure if it's a quest. I know there's a puzzle. There is a puzzle to do you can do. Yeah, you haven't done the world quest. Yeah, there's a something. You have to do something to unlock it or something. Let me see. So we will calculate T and we just plug in all the numbers. So we'll take H, put it there, take Vmax, put it there, and so. So the estimated height or the estimated time should be more or less, let's see. So H is 256,367. We don't need to be too accurate with this, so I'm just putting in the numbers. Divide that by, yeah, like that, and then divide by 2. 9 seconds. Is that correct? Let me just double check. We have height of this, Vmax 30, E, and divide by the G, divide by 2. Yeah, I think that's correct. So about more or less approximately 9 seconds. So we should expect about 9 seconds. More or less. I mean, we can... just expect maybe 9 seconds. That's more or less. Sacrifice who is a rat. Sacrifice who is a rat. Who's a rat? Okay. Okay. Alright, yeah, here's the... So, right now, we have... So, Rad suggested Lisa.
Oh, you're taking me out.
But... I mean, we have a bunch of other people here, so... Anyone you want to sacrifice? Also, I'm just gonna get a stopwatch so that way I can roughly... Yeah, so I can roughly figure out what I'm doing. I mean, so I mean, I guess we could just go with Lisa. Sorry, Lisa. I feel so sad. Bye, sorry, Lisa. Well, if anything, where is she? Don't worry, Lisa. It will only be brief.
I'll take care of it.
And we'll have to sacrifice. I feel so bad. I feel so bad, but we do what we must. So yeah, we're just gonna hit the ground. I'll just go off like this because it's not too much of a big difference. Oh, Lisa, sorry, Lisa, come on. Well, yeah. I'll just 3, 2, 1. Check if it's about 9 seconds. 3, 4, 5, 6, 7, 8, 9. It's about 10.
Going out
more or less. I mean,
tiring.
I don't know. There's probably some other things I didn't keep in mind. Okay, there we go. an extra second. Let me check the time. I actually calculate 9.28 seconds. I got closer to 10. Let me see what height I would get if it was 10. So 30 times 10 seconds minus 30 divided by 20.4 divided by 2. 277. Okay, that's a little awkward. It's 277. Ah, hold on. I mean, it's not too far off though, is the thing. It's this does look a little below the water level, so that's probably why there's a few extra meters or so.
Quit following me.
And again, I'm not timing this very accurately, so it's not like, let's see. Is it more or less roughly about sea level?
Too slow.
So this part, it seems to be the sea level. And that part over there, I think it actually is roughly sea level. Roughly speaking. Well, then again, I don't know, I am technically, I think it's close enough. What do you guys think? Do you guys think I should try to get this more accurate and then we can see what height we'll get? Do you guys want to try to get a more accurate number to compare with this one? Cuz I counted more or less about 10 seconds. I mean, it's a little bit higher than I was expecting. I was expecting it closer to be... Okay, it says do it. Rad says do it, so... Yeah, I guess we can do that. So... Question is... How do we do this? Because we need to fall into the water is the thing. We need to fall into the water because that's actually our point of reference. So we could fly off in that direction and then do a bit of algebra. Or just, we can fall off. Yeah, I think that's possible. We can fly off towards the sea, then just drop down. That seems like a possibility. Now, to give ourselves a bit more time, what I'm going to do is bring up Amber.
Leave it to me.
Because Amber has a talent of gliding champion, so that way we don't lose too many stamina on the way there. I'll once again use Traveler, and what I'm going to do is just fly off in that direction, and then I will record. I'll do a bunch of recording, and then I'll fall off, and then I'll just drop to the sea. So I'll start recording here. That will mean I will have to open DaVinci Resolve. So I will jump in this direction, and then we're going to fly out until we're above the seawater, and then we'll drop. That's more or less what we're going to do. Let me just make sure I'm angling myself correctly. That way I don't spend too much time. Okay, that's maybe more like this direction. I think that's good. So, we're recording, and let's go. So, wait a minute. Should I? I don't know if I should have jumped there. Oh, hold on. That's a little awkward. I can't just... Okay, We do gain a little height if we jump. Well, actually, how much height do we gain? A little bit. Let's start maybe here. I think that's a decent height, like more or less on this edge part here, and we'll jump. Because we do gain a bit of height from that. Okay, we'll just jump. So, we'll do that, and then we'll drop into the water, use two different equations, because we're considering two different situations. So, we go. And, well, yeah. We're going to, we're almost over the water. Okay, looking at the map here, just Just want to be far enough away. And let's go. Let's just fall. Should I wait until the... Should I drop? I don't know if I'll have enough stamina to reach the bottom is the thing. Okay, I'll just drop. So 3, 2, 1. There we go. That'll be our little recording. And from there, let's go ahead and measure the height. Let's see how well this method works. So DaVinci Resolve. We'll go open DaVinci Resolve. And, well, yeah. While we're waiting for DaVinci Resolve to open, let's just wait until for DaVinci Resolve to open. So give it a moment, and yeah. Okay, here we are in DaVinci Resolve. Let's go and put this into here. I'm gonna change the frame rate. And now we can do some measuring. So, we're going to put this into our timeline. We can mute the track. We don't need the tracks. In fact, I'll just delete it. Here we go. Let's see. Let's wait until the part where we find the part where we're actually jumping off the cliff. Let's see. How far away? Okay, we're ready. And okay, let's get rid of that. That way we can actually get a little bit more work. So we start the moment the traveler opens the wings, and we use the animation frame. So you can see here that the wings are starting to open. Make a cut, delete. Now all the way to the end. So far out, all the way to the end, and all the way until the traveler makes a splash down. Okay, we can see the traveler's in the water now, so I'll go ahead and make a cut there. And now we have to make another cut, because we have to wait for the traveler to actually stop, the moment for the traveler to drop. So we actually have two different things to consider. So right there, the wings disappear, so we have a different height. So we have two different times. Let me go to DaVinci Resolve, or not DaVinci Resolve, Painter's Side, that way I can explain to you what's happening. So, we have this equation here. We'll be using this, but H will instead, we have to split it up into two things. We have one that is just one from just gliding, and the time of gliding, which I'll call T1, and then we have to add that with the time of just falling. Free fall. So T2. There we go. So, time of gliding, we'll simply measure that in frames, and there we go. Now, I'll also say that time of measured, the velocity, gliding, falling velocity is 1.9 meters per second. I measured these. I've measured these. You can see my videos if you want to figure out all the stuff. All right. If you want me to show you which specific videos, you can ask. Anyway, so we have 1.9 meters per second, and then we are going to measure the time. All right. Go back to DaVinci Resolve. Here so we have two clips. So this whole clip here is the gliding time, and that will be 3,226 frames. Let me go back to Painter's Side. 3,226 frames. 3,226 frames. However, we need to also convert that to seconds because we need consistent units. So again, we're running this game at 60 frames in a second, so there we go. Next is the second term. That is going to be 30 meters per second multiplied by, or let me actually just make sure I'm actually, did I actually say it was 30? Yeah, 30 meters per second. Okay, 30 meters per second, and then we'll measure the time and whatnot. So, in DaVinci Resolve, we go. Then we have this second clip. It is 399 frames. So, 399 frames. Go back to Paint Tool Psi. 399 frames of falling. Again, convert that to seconds, so 60, not 60 seconds, 60 frames in a second. And then we have to subtract that by Tm, and Tm is Vmax divided by G. There we go. It's a long equation. So we have 30 meters per second. 30 meters per second divided by 20.4 meters per second squared. I have measured the gravitational acceleration with a pretty high accuracy, so you can, if you want, you can check out my videos about measuring gravity and the terminal velocity. There we go. There we go. We have h, and we all just have to plug these numbers in, and then let's see what it gets us. 1.93226 divided by 60 plus 30 times quantity 399 divided by 60 minus, not plus, minus 30 divided by 20.4 divided by 2. Oh, wow. Okay, the height is 279.598 meters. Okay. Okay, I don't know why there's such a discrepancy in like the height here and the height here. It's an extra 2 meters. Or actually like almost a 20-something meter difference. That certainly, this matters. The 20-meter difference will matter because we kind of do need a high level of accuracy here. A relatively high level of accuracy for what I'm doing here. So, I do trust the second one more because I have proven that this equation that I'm encircling here, I have proved with a lot of data that this equation is very accurate. And well, this one is also pretty accurate from what I can tell. This method, however, I think you can get a little bit of inaccuracy from the fact that, what's it called? I don't know. Let me think. Why is this first one off by like 20 or so? Let me double check my calculations here. Square root 199 squared is 24 squared, and divide that by 0.392. Okay, it is 511. Then what we have to do is take square root 572 squared minus that number squared. 256. Okay, so there is no error in calculating. At least if I calculate this out with these numbers, I get this number. Okay, I will admit that this is my first time doing this sort of method to calculate a height. But I have certainly done a lot of measurements like with this method particularly. It's actually my first time actually using this equation to measure a height, but I have measured this thing to be pretty accurate. In fact, I actually can show you on stream let me go ahead and... Yeah, let me just show you to you. Let me... Come on. Next chart. Open the source. And... Alright, I'll go to my desktop and show it. So... Oh. What the heck? Okay, I was lagging there for a second. So, let me delete this. Okay, let me, not delete it. Let me go ahead and close out DaVinci Resolve. That way I'm not lagging too hard. So, we are... You can see, yeah, okay, just focus on the red line. The red line, and you can see all these these blue dots, those are data points. Those are data points that I've measured, and, well, you can pretty much see that, it matches pretty well. In fact, if you actually look at the R-squared, which is a measure of how accurate it is at matching, the model is at matching the data, you get about 99.925% accuracy. So, yeah. This thing is pretty accurate, so I think I can trust the second number a bit more. This I think I trust this second one more. I'll go with it. So, yeah. So unfortunately, this first method was annoying. It kind of just wasted time, but well, what can you do? And this all back up. I am really quiet. Oh, hold on. Okay, I don't really know. Maybe I was just too far away from my microphone. Does it sound better now? I need to adjust my chair. My mic should be on. Yeah, my mic is on. I'm picking up stuff. Wait, what? Okay, hold on. Did I? Oh, wait. Okay. Maybe I accidentally... Oh, gosh. Let's raise that up a bit. Test. Okay. Maybe I accidentally moved something. Is it better now? How about now? I think I might have accidentally changed the slider or something. That might have been my fault. One, two, three, test. Hello. Okay, good. Yeah, thank you. Thanks, Rad. Sorry about that. It seems like I accidentally lowered the volume on my microphone in OBS. That was my fault. What was I doing? Right, I think I kind of remember what I was doing. Okay, I'm in Paintal Psi, and I have the height of something. Alright. Okay, we have the height now. Forgot what I was talking about, but oh well. What was I talking about? Oh gosh, what was I talking about? There's just height. I have height. Whatever. Okay, I think this number is accurate. So we finally have the height of the thing off the ground. So from there, you were talking about the height of the floating. Yeah, okay. I'll just continue on. So we have this height, and now what we'll do is to measure. It's trying to predict the angle, or not the angle. We'll try to see what the height should be, or yeah, more or less. So now we need to get the distance between that point in Guyun Stone Forest. Oh, I accidentally closed Photopea. My bad. Let me open that back up. Let me up. Sorry about that. Wait, radius at Teyvat check. Livestream experiments. There we go. So, there it is. Okay, so we measured the distance. So now what we need to do is to measure the distance between this point in the Sea of Clouds and this point on Serai Island. Let me just make sure that they're fully zoomed out, both of them. Yep, both of them are fully zoomed out. And well, now we got to do is to measure measure the distance between them. So we're just gonna draw a line, and then we'll adjust the positions. And it looks awkward. What I did wrong is that I need to first set this fill type to red, or that's just what I like to use. I like to use red, and I'll set the width to 0. Otherwise, it'll be too thick. You don't want to be too thick here. Otherwise, it makes it a little hard to see. So now we just gotta align that pretty well, like this. Then go all the way down here. And I think we aligned these maps pretty well, so that's fine. So next we gotta do is this, align this one. Then, from there, we now have a distance in now have the distance in pixels. So we go to this one, and we have the distance. 1773 and 1567. 1773, 1567. We have the distance. I'll use D. I'm gonna use dp divided by rho 0%. This dp is going to be square root of 1777 squared plus what was the other one? 156 what? 1567. Okay, 1567. Squared, square root, pixels, and then we have 0.392 pixels per meter. I will say this equations and whatnot, I've shown that they are also very accurate in another video of mine, so again, you can watch all these stuffs. I have a lot. I spend a lot of time. I spent a lot of time building up the physics and measurements methods for Genshin stuff. And you divide that by 0.392. Let me just double check. 0.392 is the number, right? Yeah, 0.392 pixels per meter. And that distance gives us a total distance of 6,043.936 meters. That is a lot farther away. 6,043.936 meters. Now let's recall our equations from earlier. There's a lot of them that I had to go through, so okay, we need to know the height in pixels, so we need this equation. We also need the tangent equation and theta. Oops, not that one. Where'd it go? There it is. So we need that. What was that? It was height in pixels is equal to gamma and times theta, and gamma itself is equal to a 21 points. Let me just open up the thing. 21,653. 21,653, I think. 25,653. 653. I believe that's pixels per meter, or not meter. Pixels per degree. Then we also need the other equation, which was that tangent theta is equal to the distance divided by, not divided by the distance, and what was this one? H, right? I think that was H. Yeah, and then from there we can calculate the height in pixels. Okay, yeah, I'm remembering now. So let's start off with, let's start off with the flat values. So I'm just gonna put this to the side, that way they're not gonna block us. We're assuming we're on flat Teyvat. So we calculate theta. We get that tangent theta. We substitute for the values. The height was 279 point, what was it? 0.598 meters. And you divide that by the distance, which is 6043.936 meters. Streaming for 4 hours, wow. But this time, okay, unlike the other time I spent a lot of time, in my previous stream, the first part, I spent a lot of time just being confused. But this time I am actually doing stuff, so I hope you guys find this entertaining at least. Or you find, I hope you guys find it entertaining. So, inverse tangent of the numbers, so 9, divide that by 6, okay. We get an angle of more or less 2 degrees, 2.648. Okay, Rad says you're finding it entertaining. I can tell. It's your. Yeah. Okay. It's nice. It's nice. Thank you. Okay. There we go. We have theta, and now we have h. H is going to be the height in pixels. What was the number? 21.6. What was it? 653. 653. Or actually, I'll use more decimal places. 6528. Then 6528 pixels per degree, because it's a little bit more. We have to consider a bit more accuracy. Then we multiply that by our thing in degrees. So 26.487 degrees, and with that we get 21.6528 multiplied by 57 pixels. Is that correct? No. Well, we get 57 pixels. 57.351 pixels. Okay, we have that. Now let's consider 1,778 kilometer radius Teyvat. So we know that the S is equal to D, and that will be equal to alpha times the radius of Teyvat. And then we need to compute the lost height. The lost height is equal to, I think it was like R times 1 divided by cosine alpha. Minus 1. And then we can calculate, and then we calculate a height. Let me see what I did here. So in a round, okay, I took the so HR is equal to that. Okay, yeah. So then we get HR is equal to the actual height minus, or that we measured, minus the lost height. And then from there, we can use tangent, I think. Tangent theta. Let me see. Tangent theta HR divided by S. Yeah. HR divided by S. And yeah, okay, once we have all those equations, we can then calculate HP. So HP will then just be equal to, you know, gamma times theta. There we go. So, let's start. First of all, we need to calculate alpha. So alpha is simply the radius of Teyvat was assumed to be 1,778 kilometers. And the distance is 6,000, this number. 643.936, but that is in meters. Convert to kilometers. There are 1,000 meters per kilometer. And this will give you a number in radians. So we need to convert that from radians to degrees. So there are pi radians for every 180 degrees. There we go. And then we can get the angle in degrees. By 1,778 divided by 1,000 times, times 180 divided by pi. And that will give us an angle of 0.195 degrees. Or let's use more decimal places. 174. Yeah, 47. This will be an 8 degrees. Next, we calculate this one. And we just plug in a number. So we get R 1778 multiplied by 1,000. That way we convert it to meters. Then divide by cosine of that angle. Minus 1. HL is 10.273 meters. Okay, so at a much farther distance, we lose more or less 10.273. 10.273 meters. Just making sure I'm putting in the numbers correctly. So, we lose 10 meters off of our 270, what was it? Our 270, yeah, we'll just grab this number, put it down here. And we subtract that by this number. And that will give us our new reference height. So, 279,598 minus 10 point, or yeah. Or actually, let me go ahead and use, again, we're trying to use accurate numbers. Okay, 279 plus a minus. Okay, this will give us a height of 269.325 meters. Then we can take this number, put it here, and solve for theta with the arctangent or inverse tangent function. It's a lot of work. Inverse tangent of HR, divide that by the 6,000 distance, so 6,000. Is that correct? Yeah. Angle. Wow, okay. 2.55. Why is this so close though? Why are these numbers so close to each other though? 25515 degrees. Now, let's calculate our height in pixels. So, our height in pixels, we use this one, 216216528, multiplied by that big thing. You get 55 pixel. You get 55.247 pixels. They are both pretty close. They're still pretty close to each other, even at this much farther distance. That's really awkward. Whatever the case is, we shall see. Let's go back to Photopea, and I have the screenshot, so let me bring in the screenshot into Photopea. And, well, the moment of truth. We'll see. So, here's our screenshot. So, how many pixels high off the ground is this thing? Moment of truth. Go off to the down to the horizon, and let's make sure that we're accurately doing this. So I think that was more or less about the point of the height. And does that look like to be about the horizon? Let's make sure it makes sense. Does that look about to be the horizon? I think it does. So, drum roll. Let's see. Oh wait, drum roll. 64. Okay. That is neither that is not close to either of the two. What the heck? Hold on, what? That's not even close. That's not even close to either of the two. Hold on. Okay, let me go do this backwards. Let me go backwards. So we have a height of 64 pixels. And then I could go back to a divide by 2.6528 gives us an angle in degrees. My angle should be the angle should be closer to. Wow, okay, that's interesting. At a very far distance, the but here, okay. I will say though, even though this little method I'm doing here is not the most, I mean, you know, this method here is probably not the most accurate. Okay, why is it off by that many pixels is the question. Why is it off? Okay. Am I measuring the right thing? Question 1. Am I measuring the right thing? So, we have... that, and okay, I'll go back to Genshin here for a moment. Let me go ahead and save this. Go back to Genshin, and let's take a look. 4 hours, so we're currently at 4 hours. Wow, we've been going for a while. So then we have this one. If I go back, let me go back over there, just to see.
Behold! Swan Fury!
Man, this is a lot. Holy crap. I mean, I'll be honest, I'm a little I'm actually really surprised that how much I'm spending. I was expecting that on the first live stream I would have already disproven the radius of Teyvat. But I don't know why. I'm just like it's taking me another 8 hours of experimentation and I still am not exactly sure. Let's bring back Sarah over here. Oh, I mean, we technically don't need to bring Sarah. You just need to be able to see. So let me bring it up and make it daytime so that way we can see the island in the distance. Okay, we can barely see it. I think that really is Sarai Island. It also matches based on where we put our pin here. So if I navigate this pin, it's in that direction. So I think that should be that island. Does it change? Okay, hold on a second.
Let's go get
ourselves.
ourselves.
Bring out Yella in here. Let me try this. Yella's kind of in the water. Maybe it can go a little deeper. Okay, we got our water, and then we can just go up a bit. I mean, I think it should still be more or less the same. It's just that, why is it so much higher? According to... okay. Okay, I'm once again at the point where I'm getting confused. By the way, if you're enjoying the stream, be sure to leave a like. That way, you know, it helps out the channel. Help more people get recommended and whatnot. So, height in pixels. So we measured the actual height to be 64. So I'll put this here. I'll put it the actual height was measured to be 64 pixels. That is actually quite a bit of a discrepancy. This one is closer, but I mean, to be fair, it's like it's 7 pixels off, so it's like not too accurate. However, I can say though, what I can say, however, is that, well, you know, this, I mean, I think this is actually kind of enough evidence to say that the radius of Teyvat is definitely not this, because the height in the pixels is much greater than what we would expect. So I think it's pretty safe to say that this is not correct. The thing that I'm confused about is why this thing is so off. That's the one I'm confused about. Let me try something. Okay, no. Let's see. Okay. I mean, okay, I don't know why this number in particular is off, like, by that much. It might have I don't know if it has something to do with this. I don't know if it has something to do with this constant I measured, and, like, it's not actually as constant as I think it is. or let me check. So in my, let me go to my desktop here. So granted, this is a pretty few, this is only 10 samples, but I mean, it's pretty accurate already. So if we have a height in pixels, it's more, it's less than, it's about 64. So it should be somewhere here. And yeah, it's, the angle's more or less about here. So I think that should be correct. And based on the data points, it should be there, yeah. I do think it's, why is it off though? Why is it off though? That's the, why, okay. Why is this number off? Why? Oh. Why is it off? Why is it off? Okay, let's go back to Genshin. Let's see. Okay, so that is over there. And we're over here. Okay. We go to photo P. Let me go back to here and get rid of that. So we measured the distance. So the distance we measured is 1773. Wait, 1773. Did I put 1777? Oh crap. I put 177. But that's like a tiny difference. How would that? I don't think that's enough to fix the problem though. Like, this being a 3 is like 4 compared to 3. I don't think that's gonna change much. We'll see. I don't think it shouldn't change any. It shouldn't really change anything. 1773 squared plus 1567 squared. Let me check the other number as well. 1567. 1567. Yep. So let's see. Divide that by 0.392. Oh, it's actually okay, it's a little bit smaller. So we got 36.287. Okay, that's awkward. Okay, I'll just, it's a little bit less, but I mean, who knows? Maybe it's just enough to change things. So we'll get rid of the old numbers and replace everything. So we go. We'll have to. Wow. Okay, we have to. There's a lot of stuff I have to recalculate now. Okay. Well, at least it's not too bad. Maybe I should have done this on a spreadsheet, but whatever. I like to write it out. So 287 meters. Okay. Then this number has to be recalculated. This number has to be recalculated. Everything needs to be recalculated. Okay, let's just oops, okay. Let me also save this. Okay, saved. Next. Okay, we have to recalculate this one. We have to recalculate that. So everything has to be recalculated. Let's go. So I'll save this number to D. Okay, there we go. Then we have the height, the actual height. I'll just save that also to a variable on my calculator. That way I don't need to. Store that height as, store it as Z or something. Okay. So we'll take inverse tangent of Z divided by D. Okay, that barely changed anything. That just changed it to 265. Two degrees. I don't think that's enough to real. That's still okay. That is still quite something. Here we have 64. But yeah, I don't think that shouldn't be enough to really change anything, so I don't really know why it's off. Again, this is still 57 pixels. Why is the second thing? Okay, why is that one off? Well, if anything, let's just go through the numbers with the radius of Teyvat and see what happens. So we take d, the distance divided by the radius of Teyvat divided by 1000 multiplied by 180 divided by pi. That will give us alpha of 1.9 or 5 degrees. Then we can substitute that into this. We get 1778 times 1000 multiplied by 1 divided by cosine of that angle minus 1. Yeah, the numbers are practically the same. So we have 10.247 or well 6 meters or whatever. Then minus by 10.2466 meters. Again, the numbers are practically the same, so it's not like anything was extremely far off. meters. Then we get an angle, inverse tangent of that divided by the distance. We get 2.55. How does that compare with the other one? 2.6. 2.55. 555 degrees. Then we take 216,528, multiplied it by the thing, get 55. Again, yeah, everything is still the same. So 55.322 degrees, or not degrees, pixels. What I find particularly interesting, though, is that why is it okay? This method should work, but this one, but it doesn't. But it's not accurately predicting the height. Why is it not predicting it? Excuse me. Why is the height? Why is it not correct? What could be the reason? Four hours and wow, I've been live streaming for a while. Take a sip of water while I think. Why? Okay. Maybe there's a measure in measuring the height of the floating island. Okay, maybe. Maybe that. Measuring the height of the floating island. let's see. Here's what I'll do. I trust... Okay. Hold on. Is this what...
Take it easy.
Is it actually this thing that we should be measuring from? Should it be this thing? But can you even see this much detail from that far away? No, these things don't give enough detail to really see. You can't really see these. I'm looking at the screenshot I took with Kujo-Sara. It doesn't look like it should be enough to... It doesn't look like it should be... Oops. It doesn't look like it should be enough to see those little spike things. By the way, again, this is actually kind of how actual science is. You do your experiment, you just have your results, and then you stare at it being confused, and you try to figure out what's happening. So, science is really like that. You just have to take the time to... Yeah. Because I think from these little spire things, it will give like quite a bit of an extra height, but I don't know if it'll... I feel like you should, if it was visible, you should be able to see, if it was big enough, it should be able to be visible on, yeah. Based on the measurement, or since the actual pixel height is taller, what the height should be greater than 279 meters tall. That is the game maxed out? What do you mean by maxed out? Graphics. Okay, let's try. No, okay, no, my graphics are not that high. My computer's gonna have a stroke, man. Let me go ahead. Okay, I'll close out some stuff on my computer, and yeah, let me just close out some stuff. That way, I'm not like going too hard on my computer here. Okay, close that out, Graphics, the graphics. What would be a thing that affects it? You know what, let's do environmental detail. Let's go highest, and I'll relog, and we'll see. Shadow quality, I don't think that's the one. Reflections, motion blur, bloom, crowd density. I feel like the only one that should affect it. Only increase environment detail. Okay, I'll just relog and... Okay, let me just relog. Give me a moment. Do you have to exit out of the game entirely, or do you just need to log out and then go back in? Okay, let's also... It'd be really one silly twist of fate if we were actually measuring that thing. No, that's not possible. No. That, okay. It'd be one crazy twist of fate. No, it's not possible. It can't be that thing. So just log out and log back in. Okay. Okay, well, guess we'll go back to the thing. Wow. Man.
Behold!
Okay, let's head over there.
The wind rises.
I do think it actually looks a little better. My problem is I don't have the exact position I had before anymore. I do think it actually looks a little better. But I don't know if, again, it's like... I'm not sure. Is that... Okay. That's when I zoom in. And to be honest, like, even then, like, those details are really tiny. I don't think that my height measurement in pixels would be affected too much by it. It might be like 2, maybe at most 2 pixels difference. 2 or 3, or I don't know, around 2 or maybe around 3. I don't think that's enough to get to fix the issue though, with the little bit extra detail. And not to mention, I'm also technically zoomed out when I do this thing here. So, could be that I measured the, so I don't think it has anything to do with the height of the crystal. I mean, height of those things. Yeah, I mean, yeah, it's could I? Do I have one of those portable teleporter things? Okay, I do. That way I don't need to constantly run back and forth. Let me put one down. That way I don't need to. Yeah, okay, that's much. So it lasts a week. Okay. Because as far as I can tell, these extra things here should be very tiny by the time you go 6,000 or 6 kilometers out. These little, I mean, it's barely much of a contributor to the actual height and shape of this thing. It could be that, okay, so let me look at the equations. Because maybe I did something wrong. So, in our equations, we measure theta based on this tangent function. And the tangent function makes use of 2 values. It makes use of 2 values, d and h. We also calculate the height in pixels with this constant, but it's pretty, as far as we can tell, it seems to be pretty accurate. So 6528, yeah. Let me just make sure I copied that right. 6528, yep. So the decimal places are correct. And yeah, we can calculate an angle. So if we put 64 into our calculator, okay. I'll go backwards here. I'll start with pixels, then go to an angle, then I'll put the angle into here, and then we'll see what the height spits out. I will say though that this method is, because of how big the numbers can get, the tiniest differences in angles and, you know, it adds up. It really does add up to a lot of a big discrepancy. So I'll take it with a grain of salt when we compare it with this number here. I've seen that it's not the most accurate, but yeah, because it's very sensitive. I mean, think about it. You're starting with something that's as small as like 2 degrees, and then, you know, the actual size of, like, that's only 2 degrees of your field of view, and then it's 6,000 meters away. So yeah, again, be a little careful when you come to interpreting this thing. 258 pixels per meter, divide that by 64. Then that gives us an angle of 29557 degrees. Now we put that into our tangent function and we multiply that by the distance to get the height. So tangent of, I'm just doing this on my calculator, by the way, 300, so it's about 311 meters tall. Okay, so if I get something closer to 311 meters of height, then that will be more accurate. Okay, what I will do here, okay. I was worried that the lower res model, which Genshin uses when you're far away from something, was as tall as the highest point of the island. Yeah, it's not, yeah. It's barely visible. It's not really, it doesn't really affect it too much. I mean, it does look a little clearer. I can see the ridges better, but I do admit that, I do have to say that I don't think it's that much of a difference. Again, it's probably at like 2 to 3 pixels difference. So let's, I'll do this. I'll go up to the top here and not jump, because that will... Okay, we'll do it like that, more or less. And then we'll glide down all the way to the point I was standing at earlier, which was more or less here. So, there we go. I'll stop recording. Then I'll go to DaVinci Resolve. And I have to wait for DaVinci Resolve to open again. Let me also lower my stuff again, so that way I don't explode my computer. Okay, so I'll just... Yeah, just give it a moment. Okay, go to DaVinci Resolve, and we'll just measure the height. Get rid of that. So all we gotta do is to simply measure the height of this thing. There we go. Like this. Then we just need to find where we touch the ground. Okay, I'm having one of the frames just looks duplicated. A little sad, but nothing I can do much I can do about it. So we have a total of 1060 frames. So if I do 1.9 times 1060 frames divided by 60, we get an extra 33 meters of height. So if I add that to the height that I measured earlier... Oh, what do you know? 313.1645 meters. Pretty close. I will say, it's pretty close. But if... okay. I'll run through the numbers again, but this time instead of just putting it on... I'll open up, like, a Google Sheet, because I'm just like... I'm gonna keep running... I'm gonna keep typing in all these numbers again over and over. Yeah, I'll go ahead and just... I'll just go into... I'll try to... Yeah, I'll try and do this. So if I include an extra term in this one, which is an extra few frames of height, like you add up like 1000, what was it? 1060 frames to this, you'll get a height that you'll... let me just cross that out that way. It's like, you get 313.165 meters. And if we do it if we use this number, the height actually comes out to, what was it, like 311. So it is actually, maybe it actually is that, but again, these numbers are particularly sensitive to because of how far away from each other they are, so I'm not too sure. I have to be a little careful here. Okay. Let's see. What was I doing? Right, let me go to... Genshin Science Peer Review. Okay, I'll just open up the spreadsheet. And we'll go to the desktop here. I can also close out DaVinci Resolve. I don't need it anymore. Alright, let me go ahead and... excuse me. Let me go ahead and actually put in all the numbers. So I have... Oh my gosh, I'm just like burping. Sorry. So let me just put in all the numbers just to be accurate. So we have that D in meters. We have our distance D in meters. Put that over here. We have our distance D in meters. Then, what was it? The actual thing was square root of 1... What was it? 1773. 1773 squared plus 1567 squared, and you divide that by 0.392. There we go. And next we have is another term. We have H. So H is, well, I mean, I guess I could type it out. I'll put G Vmax. This is in meters per second squared. Then Vmax is in meters per second. This one's in 30. The other one is 20.4. So 1.9 multiplied by... Okay, the number of frames, T1. This one is equal to 3226 plus the 1060 frames. Oops. But we can convert that to seconds by simply just dividing by 60. So this is in seconds. And then we have T2 in seconds, which is 1399, or 399 feet, not feet. 399 divided by 60. And need simply to, all we do is 1.9 multiplied by this number, Then we add it by 30 times the height minus Vmax divided by G divided by 2. There we go, 313, that's correct. Next we have is what do we have next? So we have to use these things. I guess another one I could bring over is gamma, so let me just, whoops, that's not what I wanted to do. Character map. Then we have gamma. Bring in this gamma. And gamma is in units of degrees per, or pixels per degree. What was it? Pixels per degree. Degrees, or pixels per degree. And that will actually just be equal to this number here. Next, flat, so we'll consider the flat Teyvat. So we have theta. Let me actually bring out the character map again. Theta. We have theta in degrees. What we have to do is to take the tangent, or a tangent function. So you can see inverse tangent in radians. I'll fix that in a second. So we have opposite. So opposite is the height divided by the opposite divided by, excuse me, this, and that's in radians, and we convert that to dear gosh, give me a second here. Degrees, so degrees, there you go, degrees of this thing. Much more accurate. Next, we consider the height in pixels. So HP in pixels is simply equal to this number multiplied by that number. So closer to 64. And now what we have to do is consider curved Teyvat. So we have a radius, and that will be equal to 1,778 kilometers, r kilometers. Next, we have to solve for alpha. So let me open up the character map again. Alpha, grab that here, copy character map alpha. Now we have s, that's the distance, and we'll divide that by the kilometers, and we divide that by 100. Oh, not 1,000, because we need to convert kilometers to meters. Next, we also need to convert that to degrees, so we can actually just use the degrees function. Is that right? I don't trust. I don't know why. I don't trust the computer to do it for me. Let me see if I can just do it myself. So if I multiply by 180 AT divided by pi, okay, it's correct. Okay. Next, so this is in degrees. Now we need to measure this, calculate HL, and HL is that formula. So let's do that. HL in meters. We take the radius, we multiply it by 1,000 to convert it to meters. Then we multiply that again by 1 divided, or do we have the secant function? Yeah, we have secant. Oh wait, the angle has to be in radians. Why? Secant is 1. Secant of, we have to use radians, so I'll convert that to radians. Minus 1. We lose 10 meters. Then we got HR, which is we take our actual height, subtract it by 10. We got HR, and now we have to solve for the theta. So theta is equal to the opposite, which is this, or degrees a tan of HR divided by this distance. And then, well, we get the height in pixels. So height in pixels, that is equal to this times this one. Once again, we are very close. Gosh dang it. So here's the actual height of the thing in pixels. So the actual height is 64. They're so close. The actual height is 64 pixels. So let's consider this. So let me put this on a table, that way it's all nice. So we have flat and curved. Then we have the actual expected height in pixels. Or let's do it this way. We'll have it like this. Height of pixels in this one is 64.3, and then this one is this. And then we have percent error. We take this number, we take the absolute value of this minus that divided by that. Let me just lock those in place. Oops. And we'll convert that to a percentage. All right. So what do you guys think? So we have, here we have. So yeah, this is our thing here. Is it significant enough to say that Teyvat is flat? Or do we have to... holy crap. I don't know if there's a way I can use. I'm not sure if there's any sort of statistical, like statistical tests I can use to potentially yeah, okay. So Rad says they consider it significant enough. Why? I'm just wondering why. Because I mean earlier, you know, I did the same calculations, and I did the calculations but with something shorter. Let me see if I still have it, or if I put it somewhere. Did I put it here? Earlier we measured yeah, this. So I'll also put that into the here. So we measured, like, what was it? 26.525 pixels, and we also measured a height, or what was it? 27.43. Come on. What the heck is happening? 27.43 for the flat. So then we have the flat and we have the curved. Like that. Oh wait, the actual thing, HP prime for this one, or HP, is actually this one is actually 64, was it? Or no, it was 28. Okay, so we had 28 here. Yeah, let me fix this. It should be this one. Okay. So earlier we measured this. So this is what's from earlier. So this one is, but this one is at a distance of about 6 kilometers. This one, however, was at a distance of, what was it, like 2.5, or yeah, 2.5 kilometers approximately. You can, I guess you can see here, like, if anything, you can kind of see that. Oh, actually, the error, whatever, the error is actually smaller, but I don't know. Ah, gosh. It's also a little awkward because, like, I mean, I don't know how many, because, like, there's not a lot of, there's not a lot of people, like, watching. I mean, Rad, you seem to be the only one who's actually, like, talking. So we have these two things here. We have one that's, I mean, whatever the case is, it always seems that the flat, is just, oh, the percent error is just under 1%. It's just that. Okay. Could be. I mean, the other one, though, I mean, yeah, there's a bit more error. Could be done by, like, man. Oh my gosh, it's been 5 hours. I've been live streaming forever. I don't know if there's any sort of statistics I can use to actually do anything to test this. I'm not sure. There might not be anything I can do. And a bit of something that's a little bit awkward. We were just barely able to see the floating island of Serai. Just barely, so it's almost out of render distance. So anything that might be farther than Serai Island, it may not even be visible anymore. So this might actually be the limits of what we can actually test in regards to the radius of Teyvat, which is a bit awkward. It'd be nice if we could actually see anything further. Like if we were able to see things farther away, then it would be possible to potentially be able to maybe actually, it might be enough to actually potentially be able to see a difference, but I don't know. Oh, whoops. Let me see. I chose Serai Island because it's pretty easy to see. Are there any... Okay. Is there anything that is visible? From such a far away distance.
Squall and Fury.
I mean, I'm probably... Are you serious? It's raining. It's still raining. Oh, it's even thundering. Oh, time to wait a bit longer. there's a chance I might need to just... Well, it seems like there's a chance I might just need to, do another live stream, which is really awkward. But the problem is, I'm not sure if there's anything I can really do about it. There is one thing I can think of. Let me see. Let me see if this will work. But I might want to save that for another stream because it's been a pretty long stream. I'm not sure if I might want to take a break because I'm getting a little tired. But okay, we can see Inazuma from all the way over here, so that's interesting. How far away is that? So is that farther? So Sarah Island to that is that far. Narukami Island at its highest point to that looks pretty far as well. Actually, I think I have an idea for how to gauge how far away it might be. So let me go to this and bring up Sayu. Matsuban, which one is it? This one. 5,000. It's okay. It's actually shorter. Okay, it's not because the height. It doesn't include the height difference. This thing includes a height difference, so therefore the horizontal distance between here and where I'm standing is less than this number. That's unfortunate. It's not far away enough. Is there anything else you could see from all the way out here?
Smile.
Man, why'd it gotta be this hard to do anything? Where is Teyvat?
Say cheese.
Got Teyvat. Oh, that's Watatsumi Island. Teyvat must be that far out. Celestia. That is interesting. But my problem is, I do not know how tall this thing is. I do not know how high this thing should be. That is an interesting... It could be... Celestia is pretty dang far away. I will admit. It is actually pretty dang far away. If I'm not mistaken, it's all the way over here, actually. But the problem is, I have no way to verify what its height is. I cannot see that tower from all the way over here, so that's a little unfortunate. Somewhere over there, Celestia. Another possibility I was considering was maybe Dragonspine, but I'm not sure if I would even be able to measure the height of Dragonspine, is the thing. And even then, it needs to be, the thing needs to be farther away than 6,000 meters. Yeah, that's awkward. The thing is, can we see it from Nachnan is the thing. If we could see the Narukami Island from Nachnan, then it could potentially allow us to actually measure. It could actually be pretty useful because it's about 13 kilometers away. So that, yeah. So I wonder, I wonder if I could see it from here because it doesn't look like I can, because it looks like the desert here is kind of getting in the way. And alright, let me see Port Ormos. Let's see. Oh, hold on a second. Okay. Brad, I'm just wondering. Are you tired? Because, like, I can end off the stream and maybe I can do some searching, searching for places or things off stream. Because if you're getting tired, I can end things off. Because it's been 5 hours. So, yeah. If anything, I do think we accomplished more in this stream than I did in the last one. I think it's more leaning towards that it's, I do think that it's more likely that, yeah, I think we're seeing that it's more likely that we're disproving that the radius is 1,778 kilometers, and it should be larger, or it should just be flat. I think that, yeah, it's a bit of an extra step. So, but I'm just personally, I'm not sure if it's enough. But then again, I don't know how. Yeah, the error. Or maybe I'll try and see if I can figure out a way if I can measure the error and predict the expected error between some stuff. But again, yeah, it's been a long stream, so I don't know if you want to rest now, so yeah. You think so too? Alright. Yeah, it's been a long stream, so yeah. Also, my headphones are about to die, and so it's a good time to end. Alright. Yeah. Well, if anything, I guess that means I will have to do a third live stream. But, we're more closer to saying that the Teyvat, that Teyvat does not have a radius, is flat, or it has a much larger radius. So, yeah. Yeah, I hope you guys enjoyed this. I hope you enjoyed the stream, and I'm probably sorry to those who probably had to go to sleep or something, because I can't imagine that my time zone is the most, well, fitted to other people's, and when I decide to stream is the most fitting. So yeah, it was a fun stream, yeah. Alright, so yeah, that's really about it for now. So thanks for watching, and hope you've enjoyed.